another, we love ourselves. Love yourself. We love this time, we love our health. Love my health. If you know what I'm saying, say that you feel me. Yes, I do. And if you don't understand, then you should really figure that out. I'm not as crazy as you think I am. Waiting patiently to bloom, praying ancient prayers to soothe, lying patiently, breaking ground and rising up in preparation to erupt, hoping spring will come too soon, too soon, too soon, too soon, too soon. Naked eyes upon the sun, watching water start to run from its frozen state of mind. Setting congregations free, liberated, so are we. Creatures wake from sleep divine, sleep divine, 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 divine. Get your boy over, my brother. Tell me we're over. We got to love one another. Got to be free to sing me so. Inside of me, can't you see that I got to be just like the Lord? I promise I'll be. Untie the bonds that made our fathers less a man. Get back to freedom that come with his land. Somebody help me. Get my paw over. Got to be free. Somebody help me. Get my paw over. Gotta get it over. Got to get it over. Get your ball over, my brother. Tell me we're over. We gotta love one another. Got to be free to save me so. Inside of me, can't you see that I got to be just like the Lord? Promise I'll be. Get back to freedom that come with the land. Let me hold my head up high and walk like a man. Free me, oh Lord. Free me, oh Lord. I got to be the man that I'm meant to be. Somebody help me. Got to be free. Somebody help me. Get my paw over. Got to get it over. Somebody help me. Somebody help me. Got to be free. Got to be free. Somebody. Somebody. Somebody help me. You know I gotta get my paw over. Gotta be free.
Got to get it over. Everybody's got to be free.
Somebody.
To get it over, everybody's got to be free.
Somebody.
To get it over, everybody's got to
Somebody
be
help
free.
me.
To get it over,
You know
everybody's
I
got
got
to
to
be
be free.
To get it over, everybody's got I gotta talk to you. 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 I got things to say. I got things to say. I've already said too much and I don't wanna rush right now. But I feel so far away. I don't wanna rush right now. I gotta talk to you. Am I making a mistake? Tell me. If you would take this chance, then I'll take it too. I have these thoughts I keep, I wanna share with you. And when I'm out of luck, I always favor you to bring me back to life. You always make me feel good. Please don't let me down. I wanna make you feel good. Please just hear me out. You always make me feel so good. Please don't let me down. This is something that means so much to me. Go with your babe, go with your babe. I'm wailing at my store, I definitely wouldn't miss a thing. When you're lost on your own and you're wondering if I'm following, just know.
Mach ein bisschen Gates runter. Ja, die sind vollkommen unterschiedlich. Das ist zu laut. Das ist das daneben. Das ist das Grüne. Das Grüne ist das zweite. Nein. Passt.
1, 2, 1, 2.
All right, let's start. It's really nice to see you here in Nuremberg again, or maybe the first time. So just a question for statistic reasons. Please raise your hand if you are here the first time at the Developer Days. The first time? Really? That's awesome. That's really cool. It's really cool to see so many new faces, so many new people the first time at the Developer Days. That's, yeah, cool. So, first off, this is a label in a shirt, so if you, that's for the boys only, so if you picked up your shirt yesterday and find a label like this in your shirt, then this marks actually a girly shirt. So, if you just put that to the cupboard and at home realize that the shirt is not fitting well, then have a look to the label, get down to the registration desk and yeah, return your shirt or exchange your shirt. You get a new one, you get a male shirt actually. So, Typo 3 Developer Days, T3DD in a nutshell, what is that all about? So, yeah, just some slogans. Actually inspiring people to share, that's the motto, the slogan of Typo 3. So, inspiring and sharing, these are the most valuable attributes of Typo 3 and especially the Typo 3 Developer Days. Then, of course, the Developer Days is a socializing and communication platform. So you will meet new developers, you will meet new people, new ideas, you can talk about anything. So please use the time that you're here for networking, for making friends, for getting new ideas, whatever. And, of course, we have several. What's with the... I'm too loud? No, okay. We have several events during the Developer Days that aim to attract new people, like the coding night, but I come to that at a later point. So, Typo 3 Developer Days is about meeting and collaboration with each other, and especially with the core team. So on the right side, we have the Typo 3 CMS core team labs. So feel free to enter at any time you want. And the guys from the core team are hanging around here at the event. Yeah, just go to them, ask the questions, whatever you like to ask. Have a nice time, have a great beer, and talk about development. So that's Typo 3 Developer Days in a nutshell. So let's go back in history to last year. We had the Typo 3 Developer Days here in Nuremberg last year already, and there was an award, and we were promoted for the Typo 3 award.
Yes. Last year I went to Amsterdam, and I didn't know why exactly, because this category wasn't properly announced in advance, but it was a Twitter poll running around for 2 months or something like that for the best community event, Typo 3 community event in that year. And I went to Amsterdam, Andrea too, and we won this award because of your votes. And I wanted to say thank you to you, because without you, this event wouldn't be that cool like it was last year. Also, thanks to all the helping hands from last year. Thanks to the team. So, this was last year's applause. Now, to this year's applause.
Yes, please. These are your helping hands. This year.
So it's nice to have the helping hands on the stage right now. So anytime you have a question, you have a problem, you don't find your way to your session room, need support in whatever reason, not maybe in whatever reason, maybe it should be related to Typo 3 or this event, then just approach the helping hands and they happily help you and provide a solution for your problem. So thank you, helping hands. This event would not be possible without some premium sponsors, or actually without sponsoring. So at this point in time, I'd like to thank Jay Weiland, Jochen Weiland, he's sitting here in the front. Thanks to Jay Weiland, to AOE Media, or the AOE company, to Punkt.de and to Hiscox. These four are our premium sponsors. So give an applause to our sponsors. Without them, this would not be possible. So let's come to some important information about the location. So first of all this is a youth hostel, and I guess we are all grown-ups, so we know how to behave and how to keep the space clean. So I'd like you to ask to pay attention on that. So if you're outside and have some garbage or smokers are standing outside, I'm a smoker myself as well, so we can use the ashtrays, so that's not a problem to move to the ashtray and put stuff there. So please keep that in mind, keep the location clean, because we all benefit from that. Another thing is you got a room key, or if you stay here in the youth hostel, you got a key at the reception, and you have to return that key until 10 o'clock in the morning on Sunday. If you lose that key, then congratulations, that's €50 that you have to pay at the reception. We have your name, your address, whatever, so there's no chance in getting away. We will find you, and at least that's €50. So please pay attention on your room key and bring that back on Sunday in the morning. There are some additional rules, like 11 p.m. In the afternoon, in the night. We have to move, or we have to reduce the outdoor activities and have to move to the third floor. So currently we are on the third floor, and if you look back, then that direction, there's a backyard, I call it, and we can be outside smoking, discussing, whatever. Of course, we can be inside this location all night, so that's okay, but reduce the outdoor activities by 11 p.m. And by 2 a.m. in the night, all activities are locked down, so get some sleep, yeah. Relax yourself, because you wanna get some information tomorrow and the next days, so you should really get some sleep. So what happens if you're hungry? Of course, we provide something to eat. So from 7 to 10 we have the breakfast time. That means at 9 o'clock, usually the sessions start. So you can decide whether you want to go to breakfast or join the sessions. Means if you want to join the sessions, then you should be finished by 9, actually. So at every day, lunchtime is at 12 o'clock to 14 o'clock. Today that was a bit reduced due to the fact that we have opening and stuff like that. And then in the evening at 6 p.m. we have dinner time until around 8 p.m. Another rule, return things. So if you take the meal tray and had your meal, then you know where you fetched that from, then please bring that back. So the use hostel style again, keep the location clean, pay attention on that. Yeah, and do the service yourself. That would be really cool, thanks. We have several session rooms. So basically we have session rooms on the first floor. So currently we are on the third floor. And on the first floor, we have the session rooms from number 1 to number 5. That is getting interesting tomorrow when we have the first real sessions, because today we only have highlight sessions, and we will outline that tomorrow as well. And currently we are in the third floor. This hall is called the AOE main hall. That's the current location. This is where all the highlight talks will happen. And then we have additional rooms also behind you, which is room number 6 and 7, and there also will be sessions. But we will repeat that tomorrow again. Connectivity, the most important thing for developers. So we are happy to provide, again, a 1 gigabit symmetric fiber internet connection. I guess you tried that out already, hopefully. If not, the SSID is not that difficult. It's T3DD16, and the password is devdays2016. So if you have not connected yet, just use it, use the SSID, and we also provide a legacy Wi-Fi connection. Thanks to NetLogix for doing that, for providing the internet connectivity, helping us to connect to the internet. NetLogix sponsored that, provided that. So give an applause to NetLogix, please. There's more to announce. Yeah, we have a system here for drinks and deposit. I hope that's the correct word in English and you know the system. If you don't know the system, I try to explain that. I provided some photos on that. In general, non-alcoholic drinks like cola, soda, whatever, is free, always. Drinks with alcohol are free, but only during the social event that is happening on Saturday. So, what do you have to do? You have to need to buy a deposit coin. Yeah, you just get that at the reception. You have to pay for that, and then, if you want to have a drink, then you go to the bar and show your, say what you want to have to drink. Then you provide your coin. The coin is taken, and you get in return something to drink. So. If you want to have the next beer, then yeah, at least you need to have a bottle or a glass or whatever, and you will get the next drink. If you don't have a bottle, that means that you probably forgot your bottle. It's standing around somewhere, and that does not help us to keep the location clean. So see, that's the educational part about that, and therefore we integrated that. As I mentioned, you have to buy beer and alcoholics, so you have to buy tokens for that. You can buy, I think, for €5 or €10, and if you don't use the tokens, you can return them on Sunday. So everything that is not used, you get your money back on Sunday for that. We take plastic, yeah? Ah, that was not a question, that was, we take plastic, cool. So this is the visualization. You just provide your money, you get the coins. Then you get these vouchers, these tokens for having something to drink. In German it's Getränke. And then you go to the bar and provide the coin, and in return you get a beer or drink or whatever. So that's, actually it's quite simple. So I try to provide that into, put that into pictures because that's much easier to explain with the words. So, event code of conduct, you know, this is an event and many people are coming together, and I just expect, or I'm quite convinced that we all are grown up, that we are smart, intelligent, we know how to behave, but there are situations where we might forget about that. So, that means the code of conduct is all about, we don't tolerate offensive behavior or violence at all. So that means also if you realize that something is going wrong in your neighborhood or in conversations, then yeah, call the police or call Mattis. So no. No, just don't hesitate to speak up and say, okay, I don't like what you're doing or that's improper behavior, and just make people aware that they are maybe crossed the border or crossed the line. So that's basically all about. And especially if you had too much beer or the beer was too delicious, then you have two possibilities. One is to be aggressive or do nonsense, but that's not good. So if you feel drunken, then yeah, just consider going to bed. That's a valid option, I think. That's fine. So because we want to share a cool time together, and yeah, that requires some rules. This is not really a rule, that's a code of conduct that we all agreed on. If you want to read further on that, then go to the Typo3 org website, community section, and there's the event code of conduct. Schedule, timing, yeah. So, what to say about that? Yeah, we start in the morning. We start at 9 o'clock in the morning. You will find this schedule on the website that are going to be updated in between during the day, so have a look there and see whether something has changed, maybe. We are going to announce these changes during this session as well. So actually, we start in the morning at 9 o'clock, then we have 30 minutes, half an hour of lightning talks. What a lightning talk is, I'm going to explain in a couple of minutes. Then after that, after these lightning talks, we actually have the real sessions for 60 minutes. And then we have a short break of 50 minutes, and then we have these highlight sessions. So the regular sessions are in parallel. So we have 5 or 6 sessions in parallel, and the highlight sessions are exclusive. The highlight sessions happen here in this room for the whole audience, or for those that are interested. And yeah, highlight exclusive, that's it. Then we have lunch, of course, and then in the afternoon we repeat the game again. Schedule highlights. So we have several top speakers here at the Typo3 Developer Days. So this evening is starting with temporal modeling about event sourcing by Matthias Verras. We had the pleasure to have a meeting with the core team yesterday, so that's really interesting. That is happening here at 5:30. Then after that session, we have the extremely defensive PHP by Marco Pivetta. And tomorrow in the morning, we have the web components highlight, which is basically a practical guide to vanilla web components that is missing here on the slides by Leon. And then on Saturday, 11 o'clock, we have a Polymer web component framework by Chris Lorenzo. So these are the highlight talks. And in addition to that, we have something in the afternoon that is on Friday and on Saturday, starting at 4 p.m. We have, so actually these are workshops, so they don't last only 60 minutes, but 120 minutes, 2 hours. And you need that time to participate in a workshop. So that's why we decided to do workshops out of that. We have Hands-on Modern JavaScript by Marco Emmerich on Friday, and on Saturday we have Pushing the Limits of PHP with React PHP, done by Christian Lück. So workshops, getting your hands dirty, learn something, try it out. These are the workshops. The schedule, lightning. So what is a lightning talk? I need to read that first to understand what is it about. Okay, so lightning talks happen prior to actual sessions. And these lightning talks are intended to give you an overview. So all the planned sessions, let's say we have 5 or 6 sessions planned for the morning or for the afternoon. You, as a participant, get a short overview for, let's say, maximum 5 minutes. So the speaker is going to present a short overview, a condensed session of what he or she is going to tell you. And you get an idea whether this is maybe too complex for you or interesting or not interesting. And after these lightning talks, you maybe learned a bit And you can decide then whether to join the session to deepen that experience or to join another session. So this is the basic idea of having lightning talks. And after that slot of lightning talks of 30 minutes, then we go to ask the audience and say, who's interested in session A? And then you raise your hand. And then we count the amount of people and arrange these amount of people that we currently don't know to the actual session rooms. So that's basically the whole procedure with the lightning talks. Easy? Yeah, cool. So at this point, of course, we have some more sponsors. So I'd like to thank the t-shirt sponsor, Erkas internet agency here from Erlangen or Nuremberg, I'm not sure, Erlangen I think. And also thanks to the pre-event sponsor, Terry was giving the pre-event today for the Google Cloud Platform. So give an applause to our sponsors. Thank you. So there is more to tell. Friday, that's tomorrow. Friday night we have, you know, we are here since Sunday, so it's not easy. So Friday tomorrow at 8 p.m. there's the coding night. So that means that we will be here in the room, or interested people will be here in the room, and it would be really cool if all of you are here in the room, since you want to do some coding stuff and learn something or improve Typo 3. So we share that night with the coding night and are supported by the Typo 3 CMS core team. So you have a direct contact with the core team. You can do coding, you can do discussion, you can create new concepts, whatever. So the whole core team is here providing you with answers or maybe with questions, depends on the topic. So that's tonight, the coding night here in this room. I'm going to... Tomorrow night. Did I say today, tonight? Tomorrow night, of course. Friday. See how I'm confused. Okay. Friday night, coding night. And we have sponsors for that. So thanks to the coding night sponsors, Host Europe and Plan2Net. And there is another event on Saturday. That's not tomorrow, but the day after tomorrow. That's enough for explanation, I think. So Saturday night, starting at 8 p.m., we have the social event, and I tried to put some pictures here. So social event is about socializing, coming together, having some nice food, joining a nice time, having discussions about whatever. Of course, you can do coding and talk about tech stuff as well, but basically that is the coming together, socializing. Have a great time. Meet your new Typo 3 Developer Days friends. And we have sponsors for them, of course, because that would not be possible without them. So thanks to Team Neuster and MPM too. And there's more. We have the Latte Art World Champion Christian Ulrich, who is providing some really great latte art shows, coffee, delicious coffee, and all that kind of specialities. I don't have a clue about that, so I'm just drinking coffee. It's really cool, really delicious, and he's doing even more, and he's world champion in that. Imagine that. And we have him here until Saturday, so he's down at the lobby. Just join that event, have a nice coffee. There are special yoga or leisure activities done by Ben van Tende that is happening on Friday and Saturday morning from 8 to 9 in the morning. There's the early morning yoga. So you will find an easy way to start relaxed into a fresh new day. So meeting downstairs at the lobby, at the entrance, and then Ben is going to collect you and give you some yoga sessions. Thanks, Ben. We have another activity which is called the Best Dressed Developer Session. Actually, this is done by Jana, so thank you. It's about funny or it's a nice and funny photography competition. I hope I put that into right words. Yeah. So the idea is to put on a dress or suit or nice looking clothes, whatever, and then you go to Jana, and she has all that equipment that is required to take nice photographs, and then there is a photo, and these photos will be collected and will be voted upon. So on Sunday, actually, we are going to have a voting on that and try to find out who is the best dressed developer here at the Developer Days. And the winner of that competition gets a free ticket for next year's Typo 3 Developer Days, T3DD16. So we don't know even when that will be, but you already have a ticket, so that's really cool. Details can be found tomorrow morning at the reception, and then you have to put your name on a list, I guess. Yeah, and I hope to provide some more information or details tomorrow, but that will happen tomorrow? On Saturday. On Saturday. Saturday. So see up here, Saturday, that's the things in bold are most the correct ones. The list is there tomorrow. So that was correct, okay? You find the list tomorrow, and the best dressed back-end session is on Saturday. Okay, I think now I got that correct. There are more special activities because we are in a castle, we are in a castle and a historic city like Nuremberg. So tonight from 8 p.m. to 10 p.m. we have night watch tours. So you can go through Nuremberg and go on the road of night watch man, whatever that is called. We have in total 3 tours with a maximum of 33 people for each. That sums up to 100 people in total can participate in that night watch tour. So hurry up or be in time if you want to join that. Meeting point is at 8 o'clock this evening at the lobby or at the entrance. Then every day you have the possibility to visit the rock-cut cellars of Nuremberg. That's from 11 a.m. to 5 p.m. And what you need for that, so thanks Marco for providing your lanyard, your name tag. So all you need is your name tag, and you go to the registration of the castle, and then they realize, okay, you're from these famous developer days. I'm handing over to Tom, he knows better.
Oh shit. Why are you that low in your voice? Okay. There is an old city brewery roughly 500 meters away from here, and there is a registration, and you can look up on the page historischeFelsengänge.de what are the dates for the tours. We have arranged something with this historische Felsengänge tour, and on that list you can see how many spaces are left there, and basically go there some minutes before that starts, get a ticket with your badge and join the tour. It's not in the castle here, it's downstairs in the old city. Look that up on the page and you will find that. There's also an English version of the page.
Okay, thanks Tom for correcting that. So historischeFelsengänge.de, that's the website. And there you find the accordant information and hopefully also a map where to go if you want to join that session. So it's about brewery, distillery, alcohol, you know, too much, go to bed. Okay. We have further sponsors, we have value sponsors and supporters, so give an applause please to Hetzner and to Rheinschafe. Oh, I just was remarked that I forgot DKD, Internet Agentur from Frankfurt, as a premium sponsor, so sorry for that. DKD is a premium sponsor, and thanks to DKD as well. And more to give applause for is the organizers. So thanks to the local organizers and also foreign organizers. So thanks to DV, Chinas Datenverarbeitung and NetLogics. Thank you. So I think basically that's it. So enough said for the time being, though there will be more tomorrow morning. So I'm doing announcements every morning or when that is required. So for the time being, enjoy the Typo 3 Developer Days, have a cool time here, make new friends, take great inspirations, and yeah, just have a cool time. And we are going to continue right now, that depends on you. Or we can have a break. Continue, break, continue.
We continue with the break.
Okay, that means we have a very short break to plug in the computers and stuff, and then we continue with the keynote. So, thank you, have a nice time.
Tadadadada. Ja, läuft. Ich werde einfach lauter sprechen. Hast du mir die Bässe rausgedreht komplett, kann das sein? Bässe weg. I feel so tiny. Ja. Nee, rein. Rein, es klingt zu dünn. Oder, ja, ich meine, du kennst die Akustik besser. Ja, läuft. das funktioniert. Works every time. Awesome. Hello everyone. I'll be doing the keynote by myself today because unfortunately Benny Mack turned out to be sick. He's kind of all right, he just needs a bit more sleep, and I guess he will be with us this night somehow. So, welcome to Nuremberg, to the Developer Days, where we want to meet, talk, and code. That will be the basic idea. And we prepared a couple of things, and we'll just start right away. So let's talk CMS7. CMS7 was the release that we did, or we kind of finalized also last year. And what we want to focus on in regards to the core team about what we said, what actually happened, and in the end, what people said about that. So, when we started the 7 release cycle, we, as the core team, said that we wanted to have, first off, the new backend look, right? Most of you might notice that. We wanted to focus more on editors, giving them more functionality to work in their daily jobs. We wanted to have a more reliable release cycle, because I don't know if you remember, but the previous release cycles were kind of spiky. And of course, we wanted to build a faster system, but that's standard stuff, right? We tell that all the time. And in the end, we wanted to modernize the entire code base, so Typo 3 becomes more of a competitive system again. The interesting thing is what really happened, so what we were able to achieve. And this is going to be a lot of stuff. So we got the new backend look, so we can check that off. That worked. We supplied a lot of help for editors. And it was very interesting because yesterday we had a really, really hard time preparing the keynote, coming up with all the stuff that we actually added because there's so much of it. So this is just a list of things that we added. So we got the image cropping in place. We got the form extension, which has been streamlined and it's more simple to use. We basically built the entire backend in a responsive manner, something that most of you maybe don't even notice as something new. We got the online media, which gave us great feedback from the outside. We got this razor-sharp icons in the backend anywhere else. And this is just a lot of stuff that I probably forgot, but time was short. So this is another thing where we say, okay, editorial aid for editors, so that worked. Interesting thing is that we measured an up to 4 times speed increase in the overall system, which is also, I think, pretty well. The interesting thing is, on a side note, is you might have realized that we're the only PHP project that has undergone a huge architectural change, and actually it runs faster than before. So if you take stuff like other content management systems that have had big releases in the past, or a huge online shop, everything just runs slower than before. We figured that would be stupid, so we made the system faster. Another thing is that we dropped a lot of old code and replaced it with better code that's more streamlined, which led to the speed increase, by the way. So everything that we have in performance increase right here has nothing to do with performance-related patches. It's just architectural changes, which shows that a better code base also performs better. So whenever someone in your company goes like, yeah, it's a dirty hack, but it's because of performance, he's lying. And one of the most remarkable things I think we achieved was we actually delivered everything on time. So we had a timetable going, I think, 14 months in advance with dedicated dates. So we didn't have like a month planned when we wanted to release, but we had a strict date attached to that. And we delivered on time every time except once, where we had a critical security issue and we figured, well, securing your websites might be more important than shipping on time. Hope you all bear with me. What was really interesting is what really happened in the end. So what we can see is from the feedback that we get is that editors simply love the system. They go like, well, it looks more fresh, it's faster to use, it works on different devices, editors love it. And what we've seen from that is that market share starts to pick up again. So it's more project requests coming in, basically resulting in more business for everybody of you. Another cool thing is that developers start to pick up the system again, because it used to be this whole, it's old, but old isn't necessarily bad, but it was uncool, so we thought, let's make the code cool again, so developers pick up the system again, and it works. Another important thing is that new people get attracted, again, because we had times when Typo 3 was at its peak, where the attraction of the system was very, very big. And we got some things up our sleeves to even increase that momentum even more. And another important and interesting thing is that basically the industry starts approaching us, building solutions together with huge players from the international digital industry, because they see the potential in Typo 3, and they kind of want to get on that train right now. So I think we're actually in pretty good shape. So Benny and I had thought a lot about the next slide, and I don't know if it's possible. I think we got like 250 people here, but do you think it's possible to get something done like the next slide, maybe? So what do you guys say in general? Typo 3.7, thumbs up, thumbs down? First off, thanks for that. It wouldn't be possible with the efforts of the core team and all the external contributors that really worked their asses off to make CMS7 such a great release, and wouldn't it be possible without you, so thanks a lot. It's cool. We got time. There's a couple of people, though, that go like, this is not enough, right? You should do more things, do more drastic changes to the system, faster changes to the system. You should be revolutionary. Well, we figured that revolution is war, and normally when you think about revolution, it never ends so well for a lot of people. We think that evolution is harmony, so we think evolution might make more sense. Steps, smaller steps, but consistent steps, simply to evolve the system even more, without, like simply rushing over people or dragging them out, chopping their heads off and stuff. Okay, so let's talk about the stuff that we're doing today with version 8. We only got 2 minor topics for that. First off, I think most of you are interested in technology, so what's happening on the technology side of things within the 8 branch. And the other thing is visibility. This might not make sense to you right now. Trust me, it will later. Okay, so let's talk tech. One of the biggest changes we did right now is the T3DD16 integration into Typo 3. We figured that this is by far the biggest change we've done to the Typo 3 code base ever. It's, I think we started out with 1,800 places where the old database abstraction layer was used, and we had to replace each and every one of them. And what might sound simple at first is something extremely difficult, because it's not about just simply rewriting a select query. You need to make sure that it returns the same stuff as before. And also we figured that while we were at it, why not make it simpler for developers to use that API? So who's ever had problems selecting the right stuff based on the current language or workspace? There's helper methods for that. Most of the stuff is enabled by default. Who's ever put like deleted or hidden records on a live machine and had to talk to his boss about this later? This is stuff you now need to actively disable if you want to show deleted records. So it's enabled by default. You just focus on what data you want to select, not based on which metadata you want to select these things. This is actually pretty decent. You could figure out that this is kind of breaking, but we came up with the core team to supply a solution to that problem, and this is why the development for T3DD16 for CMS7 has started today. So this means you will be able in the near future to simply install an extension and have all of Doctrine section. I see some eyes getting bigger here. You can. You can basically take your Doctrine extension, put it into CMS7, and start writing code for extensions that supports both CMS7 and CMS8 already. So that's what we're aiming for right now. Another cool thing that kind of went under the radar for whatever reason is standalone Fluid. Who has heard of? Okay, so I can skip the question, who has heard of that? So, in case you haven't, and my freaking thing works, Fluid templating is now a library on GitHub that you can basically use in any PHP project. And we put this into works already. So we ported an application which is Forger, maybe some of you know that, to a Laravel front end, but still we're able to reuse the Fluid templates in it. And the cool thing is that it starts to render like almost twice as fast with a much, much lower footprint memory-wise. So it's extremely lightweight. But what's really cool is the stuff you don't need, which means it's highly extensible. And this is the things where you figure out, oh, you know what would be really cool if I was able to do this and that. And you realize, hey, it can be done. So it's an extremely modular approach to templating, and it has a lot of benefits over other templating engines, let's say, take Twig, for example. Twig's solution to everything is, well, just write PHP. I know quite a lot of managers who don't want certain junior developers to write PHP, because it's just like, and the other cool thing about Fluid, and I think this is the greatest benefit, is that you can actually like test it on syntax errors and stuff before rolling it into production. So having your Fluid templates being checked for syntax and validity prior to rolling them out is one of the main benefits, and basically Typo-3 Fluid is the only thing that offers that on the market. Moving on next, maybe, that's better, it's cloud hosting. Cloud hosting is one of the most controversial topics I have learned, because most of the people in the room are just like, And I hope a lot of you attended the talk by Ryan this morning, because this shows the true potential of cloud hosting. And we're in an industry partnership with Microsoft and Platform.sh to make Typo-3 work on these platforms. The good thing is that the principles repeat, so it doesn't matter which cloud vendor you basically choose for. It's just the principles are the same. So we're aiming for making Typo-3 working on a read-only file system, for example, which is what most cloud providers do. So you build your entire application, deploy it onto a read-only file system, which makes the standard attacks on servers, with defacement and stuff and backdoor injection, impossible. Yeah? If some guy tries to alter your files, well, good luck with that. It's read-only. No way to do that. Another point in cloud hosting is that we can move away from MySQL as a database onto more mature systems, say SQL Server, Oracle, DB2, these kind of things. And we're putting a lot of effort into making this work, even though you don't need it today. But trust me, in a couple of years, you will be happy that when the cloud waves truly hits continental Europe, that it's in place. Another cool thing is CK Editor. You might have noticed that we will drop HTML area, the wonderful rich text thing with a more modern code base. There's actually, this is not really a plan, but there's a patch pending already that you can just check out and apply it to the master branch, and you can see how CK Editor actually works. We figured that it uses a lot less memory on Chrome than HTML area did, which is a good thing for power editors and stuff. And integrating CK Editor into the Typo-3 core leads directly to the next important topic that we're working on, that's front-end editing. There's the guys from Pixelant. Yeah, you'll find him, it's cool. who stood up to the task and said, okay, we want to do this. The core team doesn't have the manpower to do so within the time frame scheduled for these 8 branch. So Pixeland jumped in and said, okay, we got the developers. Can you guide us, mentor us through the process? So we got front-end editing within Typo3 version 8. And I think that deserves a huge applause because it shows just how people can do things out of themselves. So it's not just the core team that survives that. Right. And now you have to deliver. So, cool. So, let's talk visibility for a moment. Visibility is basically how the system is, like seen from the outside world. And I think we should start with Slack. We think that Slack brought a huge number of positive things to the Typo3 community, which was like that it decreased support times by a magnitude. So in the CMS channel or in extension channels, you can see people just going on Slack, asking a question, and go home with a solution 5 minutes later. Also, Slack basically increased communication because it was never so easy to get in touch with huge parts of the core team. Just jump into the channel, come up with an idea, let's discuss things. That's awesome. But Slack has one major drawback, and that it basically almost killed persistent support, which means everything you do in Slack is volatile, right? So that's a discussion, or somebody asks a question, gets a solution, 2 minutes later it's gone, it's scrolled off. And the persistent support, which is stuff you basically find on Google, almost dropped to 0. And this is something where I need the help of everybody in the room and everybody who's available within Typo3. Yesterday, the core team decided to move all support activity to Stack Overflow and Stack Overflow only. So this means that whenever you have a question or something, come in on Slack and post the link to your Stack Overflow question, please, so that we can answer the questions over there in order to help more people with that. One minor remark, please tag your question with Typo3, not Typo3-6.2 or Typo3- or fluid templating or whatever. Just use the Typo3 tag and then use additional tags that makes it easier. And this would be pretty helpful for everybody if we would just join in and constantly remind each other to put persistent questions onto Stack Overflow. This doesn't mean we will be shutting down Slack, don't get me wrong. Slack is awesome for short-term discussion, exchanging ideas, that's cool, but let's move support to Stack Overflow to make Typo3 even more visible. Another topic which is kind of related is that we will, we will encourage, or want to encourage each and everybody of you to move your extension development to GitHub. We will, or alike, but GitHub is basically, it's the biggest player in the industry anyways. So what we want to achieve is that we have less load on Typo3's infrastructure, and a lot of people already moved to GitHub anyways, and it works perfect for projects of a size of an extension. And it would help that we wouldn't have to maintain our own infrastructure right now, because it's a lot of machines running just to support issue tracking for an extension that gets 2 issues a decade. So we also want to integrate the Typo3 TER more deeply with GitHub and supply best practices for that. And this also means, for example, if you do a GitHub project, register it into TER, we can then automatically create a channel on Slack, for example, and support supply tags for Stack Overflow. So all these things kind of grab in each other to make it more consistent, and we don't get such a divided base of where to find stuff. So if you're doing extension development, please move to GitHub. If you have problems with that, issues, or you just think, how can it be done? I'm unsure how to deal with things. We're here, just ask us, or on Stack Overflow. so we can make these things happen. So I got one tiny thing for you. That's one of the services of Typo 3 Inc. that has been founded. Who has problems finding proper colleagues? Proper colleagues are more people. So nobody is flooded with work and needs more developers? Ah, see? So we came up with something with a pretty decent idea, which we called Send Your Junior. And the entire idea is that what you can do is that you can send your new colleague to our office for a couple of months. Yes, and we're serious about the month stuff. Where they can learn structure and discipline. Code-wise, okay, code-wise. And what you will be able to do, you'll be able to opt into 3 different categories. So you can either say, I want to learn how to work with the Typo 3 core in general, or I want to be part of the internal projects that we do within Typo 3 Inc., or you can work within the support team, so you learn to talk to people. What's really interesting is we're offering this for free, so you can simply sign up. We got a couple of spaces left. So if you think that you could need like a kickstart or something, go approach your boss, ask him if that's a possibility. I recommend highly, though, that you do coding night first and then decide. Because coding night can be really tough, and you're signing up for months of that. So this is something to consider in that point. All right. Now we talked enough about us and what we did. So the important stuff for us is what can you people do in order to make Typo 3 even more successful than it already is. So our main wishes for everybody in the community is use CMS8 as of today. By the way, in case you didn't know, we released 2 days ago, the 8.3 version. Very important, just give us feedback. The better qualified, the better, but still, just give feedback. Stuff you see, just tell us, make good tickets that would help the team a lot. Come in contact with us, inspire ideas, come up with something yourself that you want to implement, just discuss things. Because it's not, if you have a great idea of a feature you want to see in the core, just go do it. We got mentors, more than enough mentors in the core team, which you can approach, they will guide you through the process, and you can have your own special feature in the core if it makes sense for the entire product. Then still, we're not short on tasks. There's enough stuff to do, and simply join the team. Questions? Oh, come on. Seriously?
What will happen with the git.typo3.org? Do we will shut down the Git repository?
Why would we do that?
You installed and built your extensions on GitHub.
Yes.
So do we need Git repository for Typo3?
Well, the thing is, I can ask you to do this. I cannot force you to. Well, I could try. But I would more likely try to convince you to do so. No, seriously. The thing is that the Typo 3 project supplied that infrastructure. First of all, did everybody get the question? Yes, no, that's awesome. A single no is enough for me. So Stefan asked, will we shut down git.typo3.org? Well, we'd love to, and we will, when the last extension is gone from that place. So no extension is left behind. All we want to do is to try and encourage you to use that so we can reduce the load on our own systems. And if we say we want to reduce the load on the server team, that sounds pretty egoistic. But if you think about it, it's more about fragmentation. So say you're a new developer, and there were a lot of people here that were on the developer days for the first time. And they will ask you, where do I put my extension? So 5 people will give 10 answers, and they're all totally valid. And I think we should try to reduce the amount of fragmentation and focus more on best practices. So you can have like a more streamlined ecosystem that everybody gets. Does that answer the question? Awesome. Any more questions, or are you all just perfect?
Would you encourage other extension authors to put their extension on packages?
I don't have an answer for that. Did everybody get the question? Perfect. I'll just do it. You see, I'm stalling here. Now, the question was, do we encourage everybody to put their extensions on packages? Yes and no. From a security point of view, yes. Because if you do your own stuff, people could hijack your extension keys on packages and do weird stuff with that. But we're still waiting on an answer of Jordi, who is hosting packages, because every package you register at his location results in effective cost immediately. So all I can do is encourage everybody to buy a torrent proxy license, not because you need it, just you have it lying around, because that basically helps Jordi get along. That would be perfect. So we don't have an answer on that yet, although it's on our agenda to supply a best practice for that. Because the current problem is that we see with fragmentation is that we have packages and composer type of 3 org. And nobody knows which one to pick, and other people just go like, okay, I don't want to wait this, I think it's an hour until data is imported into composer type of 3 org, so I want to have my stuff on packages right away so I can push fixes faster, and we already have fragmentation, and this is a bad thing. So stay tuned, we will come up with a solution once Jordi has, I think he's on vacation right now. More questions? Perfect. Yes. Yes. So the question was, when will we relaunch typo3.org? Yeah. I thought about starting with what's wrong with it. Okay, but we all know what's wrong with it. No, the thing is that we had a couple of teams trying to do the relaunch, and right now typo3.org is incredibly complex because there's a lot of tiny services and vital parts of that, and there's a lot of like tightly coupled applications. So just imagine you would start your PHP class with a class constructor and just jump 18 arguments in that. That's how typo3 kind of is. Typo3.org. It sure used to be. No, but seriously. So what we're currently doing is that we're trying to take out more and more simple parts of that. So for example, the single sign-on will be replaced with an LDAP-based solution. So you could, if you would love to, you could simply use the backend authentication against typo3.org. And everybody from the core team gains instant admin access to your installation. But yeah, all these tiny things that we're constantly pulling out of that, and just in order to make the relaunch manageable. And we've relaunched typo3.com 2 days ago, which also will take over content from typo3.org to make it, like more manageable. It's on our to-do list, and help is highly appreciated. More questions? Perfect. So I say, everybody start your engines, enjoy the developer days. Great, you're all here. Perfect.
They say you'll never know.
Yeah. When he asked me if I had something to say to the world, Dipped on the scale, had my mind in a twirl and realized I was carrying the weight of the world. Who else would bear the burden, give the shirt on their back, rejuvenate the streets and rehabilitate rap? You see these minds is trapped and I can see where they at, living in these fantasies that's about to collapse. I see a breach in their heart when I reach in their heart and grab them before more ignorant starts to kill our communities, drain our true abilities, frame us. The picture's the same, most of y'all feeling me, the rest of y'all not, cause you're missing the point, trying to blow up the spot and fill the slot of a new age slave. It's a shame how our people behave, got our roots turning over in graves, gotta walk on the path that they pave. I'm not the first or the last of the braves to break chains.
But come to think about it, I want to get free and ease my mind, but I just can't get away. And come to think about it, I want to get free and ease my mind, but we gotta find a better way.
Yo, what up, kinfolk? How you been, low? Seem like the world going all up in smoke. I can't complain, I maintain. I'm making moves, I gotta get paid. Know what I'm talking about? I'm about it, yep, your boy's about it. I got it together, now I'm hot, so don't doubt it. Shut down all the clowns when I shout it. Shout, shout, let it all out. It's the FAT, bitch, ask about it. Know what I'm saying? Cause I'm these mashing, Trey be mashing. Sierra singing on the hook with that passion like, yeah. You know, sometimes when you're surrounded around a lot of haters, a lot of negative. Gotta get away from the negativity. Can't nobody let nobody stomp your light out, stop your shine, take away your beauty.
Well, come to think about it, I want to get free and ease my mind, but I just can't get away. And come to think about it, I want to get free and ease my mind, but we gotta find a better way.
I have no clue of what you go through. I don't know how you do what you do, but you must been blessed with the strength to deal with the stress. The way you separate yourself from the rest is so fresh, and yes, you give them all something to talk about. They all need something to talk about, might as well be you. The people wanna see what you all about and see if you gon' give it your all amount. That's all that counts. I wonder how it feels to be you. 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 I wonder how it feels.
Come to think about it, I want to get free and ease my mind, but I just can't get away. And come to think about it, I want to get free and ease my mind, but we gotta find a better way. Well, come to think about it, I want to get free and ease my mind, but I just can't get away. And come to think about it, I want to get free and ease my mind, but we gotta find a better way.
Yeah. Jazz. What more can I say, man? A lot of our music, all of our early stuff, all the stuff we doing now, as a matter of fact, came from jazz. Wes Montgomery, Cal Jada, Monk, Coltrane. It's just dope, man, because now, in the new and improved 2008 version, we got artists that come over here to get love, just like the jazz cats did back in the day. It's just how it is, man. I get inspired by all of that, man. All the ones that came before us. That's what allows us to do what we do today. So for all of those that's passed away, Ashe, 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 Ashe.
then thank the sky. 'Cause it just might be the last time. Oh my, I've been giving up the phone for just a few years now. Enough to make it cool to find guys. And sometimes I think about growing old without ever having made this thing mine. A bump that I'ma get it on while these bones are fit to grind. We all got a good thing to give a try. Yeah, feeling right. The air is so thick, all the beautiful people get high tonight. Dig your feet into the ground and make a sound. This ain't the time for being polite. Don't think twice. If you're feeling uptight, just do your own thing. See, you might. Sometimes we like to ask the questions why. If anything to suit our mind. Oh my, I've been making up all kinds of answers these years now. None of them really that fly. And all day, every day playing my role. A beautiful game by design. A play on, got to vibrate while these bones are fit to grind. We all got a good thing to give a try. Yeah, feeling right. The air is so thick, all the beautiful people get high tonight. Dig your feet into the ground and make a sound. This ain't the time for being polite. Don't think twice. If you're feeling uptight, just do your own thing. See, you might feeling right. The air is so thick, all the beautiful people getting high tonight. Dig your feet into the ground and make a sound. This ain't the time for being polite. Don't think twice. If you're feeling uptight, just do your own thing. See, you might take it slow. Feeling uptight, do your own thing. See, you might feel right. The air is so thick, all the beautiful people getting high tonight. right. Do your own thing, Take the time to live a life. Don't think twice. Give me all the time. Can't you see I'm trying to get higher? Give me these wings to take flight. Hands up to the sky. Give me more. Give me all the time. Can't you see I'm trying to get higher? Give me these wings to take flight. Hands up to the sky. Give me more. Give me all the time. Can't you see I'm trying to get higher? Give me these wings to take flight. Hands up to the sky. Give me more. Give me all the time. Can't you see I'm trying to get higher? Give me these wings to take flight. Hands up to the sky. Can't you see I'm trying to get higher? Give me these wings to take flight. Can't you see I'm trying to get higher? Give me these wings to take flight. Hands up to the sky.
What do you say to people who have no homes? Is it Astrodome or Superdome or moving with a relative? But then that's relative when you have to move from NO to Alaska or Utah and you saw how they feel about you on the news.
What you mean I ain't making no money off this hip-hop shit? Yeah, I know this is all I do is stay up and make beats. You know, this is how we make our living. This is what people want us to do. Now, I'm not gonna get a job there, and I'm not gonna work there. You know, all that gap. Fucking ain't. Come over here, let's listen to this one.
It was me and Double K in my room in 95, beatboxing on the mic, recording the tape live. Before we arrived on the scene, you know what I mean. When it was all about, I forgot, man, forget it. See, now the P is sweated as a global affair, but it seems those closest to me seem the least to care. When it was rah-rah, y'all can do it back in the day. Now it's like 3 albums deep, and when are you getting paid? My records are played, I sleep smiling every night. But when I wake up, it's something else, a whole new fight. Like cats double-crossing me, that I try to help out. If it wasn't for me and Double, that shit wouldn't come out. So recognize who's the guys devoting their life to it. Sacrifice stability to flex our ability. Crew the iller artillery, I can't chill until we fulfill the plan of having mics in their hand. The sole reason I was cast down on this land is to sit in front of the MPC and turn the bland to the flambe. Things to play to make your day. Same shit 10 years ago I'm doing today, and 10 years from now, so don't ask how or even why. B-boy for life, fuck a suit and a tie, cause I'll know I made the difference on the day that I die. Hey yo, I'm B-boy for life, so fuck a suit and a tie.
Yeah, I feel you, man. See me talking that old bullshit, you know. You know, maybe you should get out and go get a job, you know. Or we can't spend enough time, you know what I'm saying, man? Just like you, Big Dutch, man, I've spent all my life trying to do this hip-hop shit. I think it was like 95, 96 when I perfected my track skills on the SP. Murdered 10 seconds in a minute, peers couldn't get it. Mike was walking on water, my brother, you should have seen it. Got ate up in some rap battles, I'm here to redeem it. Like a rain check hustler, scoping the aisles, jotting lyrics, making beats just to keep it on file. Whether that zip or floppy, never coming sloppy. No reason to copy niggas, I'm dope, so go big and I concede it, nigga. I'm confident when I'm dropping it. Hold the microphone firm, let the lyrics burn like the Buddha to the Sherm. I'm mellow with one word, two letter K's, bringing better days when I bust. Stay grounded with my head in the clouds, and that's a must, you know. Just a piece in my hip-hop black book, outlining the track, y'all. Watch for the hook, filling in my ideas, here to keep your style shook. Never rapping like nigga just to be in the game. I'm coming from the inside till y'all remember my name. Yo, it's the K-Dub, trouble bringing notorious one. Couldn't be stopped, keeping these sucker crews on the run. You dig it? No matter what y'all say, do or know, it's me and that's one. Maintain it. You know how it goes, man. It's me and that's one, like always. It's two of us. Keeping it live, keeping it fresh. I don't know, man. Sometimes I just feel like you can't take it no more, man. Like we just gonna bust back, you know, back rapping, back rapping. Yeah, yeah, we back rapping. Back rapping and slapping all you fools in the face. You're just a disgrace to the. Yeah, I like how that sounds right there, man. It's real mellow, real jazzy, like you dig. Ow. Word out. Ow. Word up, word up. Ow. Word up. That's one. And the double. Get by and my man. Yeah. Set my he in the house. Yeah. The double. It's the he in the house. Yeah. We all in the house. Whatever. Never leave until the beats. Yeah. Suck 'em.
So, all right, and welcome back again. I have a short announcement, and I hope that you all found well right or up to now at the Typo 3 Developer Days. I have a short announcement because tomorrow in the morning we have that Typo 3 certification here in the castle, and today there's a preparation workshop. So if you have questions on the Typo 3 certification, then I'd like to announce that preparation workshop, which is here on the 3rd floor at 4:45. That's 16:45, 4:45 this afternoon in room number 7. So that's behind you and then on the left side. So if you want to participate in the certification tomorrow, then please join the workshop. You can join spontaneously, and then you get any questions answered probably that you might have, and then you can decide whether you want to join the workshop and the certification tomorrow. But now, and I think we can start, I'm happy to have him here. Matthias Verras is going to tell us something or very interesting things about temporal modeling. We had the pleasure to work with the core team yesterday, a whole workshop with temporal modeling, event sourcing, and all these interesting topics. I'm glad to have you here. Matthias,
thank you.
The stage is yours.
Thanks, and thanks Thomas for inviting me. So this is a picture of what we did yesterday. I'll tell you about it in a moment. So I'm an independent consultant from Belgium. I have a small company, well, it's mostly me, and some other people occasionally. And I visit companies and I help them with analysis and modeling, especially for complex environments, sometimes coding as well. And what I'm going to talk about is temporal modeling. So first of all, a word of warning, it's not going to be a programming talk, it's not going to be about code. There's never enough time. But hopefully at least it will help you to change how you look at modeling complex problems in complex environments, complex domains. So who here does this? Who models? Who is, when you're trying to build some software, solve a problem, do you go to a whiteboard, do you make drawings, do you have discussions about it? So maybe raise your hand if you do this regularly. Excellent, a couple of people. Right. So maybe another bit of warning, I'm not talking about, when I say model, I'm not talking about an object that you persist in the database. That's something I would call an entity, maybe. We tend to call this model in software, but this is a very reductionist term, I would say, in this sense. So my argument is, in fact, that you are always modeling. You're always mental modeling. When somebody explains something to you, a client or somebody from the business comes to you and says, we want a feature that works this way and it does these things, you're already building a mental model in your head. Right? So if we do this and we don't visualize this, there's really no point, because you're building this model, but you have no idea of knowing, no way of knowing if this is what they actually meant. if this actually works for what they meant, if this reflects this problem well enough. So a great model is, we tend to, sometimes you hear this, especially in the domain-driven design community, where people think that a model is supposed to be an accurate representation of reality. That's not necessarily the point. Of course, we like our models to be inspired by reality. But this is a vague thing anyway. What is reality? One way of looking at reality might be completely different from somebody else's. So what we're looking for is abstractions, useful abstractions that help us solve problems. You've probably heard at some point the quote by George Box, all models are wrong, but some are useful. This is our heuristic. This is our tool for deciding, is this a valid model? If it turns out to be harder to work with than we hoped, if it's a lot of boilerplate that we have to do, if it's hard to understand, it may be beautiful, it may be very elegant, it may give you great pleasure that you were smart enough to come up with it, but it's not a very useful model, so it's not a good one. So this talk is about this, what Weinberg calls the grand dichotomy of things and process. He's talking about this in a book on system analysis and design. If you haven't heard of Weinberg, Gerald Weinberg, he was a computer programmer, not before your father was born, but before your grandfather was born. He's still alive. He's still writing books. He's written about 50 books, most of them on software and systems and analysis, quality of software, psychology of software even. Well, read all of them. But so in this book he writes about system analysis, and he says we have two ways of looking at these systems. One is things, structure, right? And the other is processes. How does this thing behave? What happens in these systems? And it turns out in software we're really over-focusing on the things. What we do is we build structural models, right? We look at artifacts, we look at state, we build an object and we make diagrams and we draw the properties of that object, but we're not really thinking a lot about how these things behave and how these systems evolve over time. So this is sort of on the processes side. That's the things that I'm really interested in. So behavior, state changes, not just state, but how do we get there and how do we move? And that's the stuff I'm looking for, especially when I'm working with clients, or what we did yesterday with the core team, trying to look at not just pages or content or articles, but how do these get built? How do these get published? What are the workflows? I think those are usually the more interesting and more complex problems. So Weinberg goes on and describes in processes, there's these three types of processes: being, behaving, and becoming. 3 Bs. Right? Being is how the system maintains its structure. So it's not just about the structure, but it's the processes that help a system stay as it is. Right? It's about the constant structure over time, the things that don't change, the morphology, for example. So this is one kind of processes. How does the system keep things as they are? Second one is behaving. And this is usually the stuff that we're most interested in when building software systems. This is, how does this react to inputs? So something happens, somebody does something, how does this system react? What's the next thing? What's the next thing? In fact, if you look at, there's a lot of these trends in software. Reactive programming, functional reactive programming. In the front ends, we're building more things like React. The name gives it away. So it's about this behavior. It's about repeatable things, reversible processes. Somebody does something, what happens next? And then the third B, the becoming, is when the system fundamentally changes. So how this system becomes something else, right? It's the evolution of the system. It can be the learning of the system. How does this system, from inputs, not just react to them, but also changes itself over time? And sort of extreme cases in software could be genetic algorithms that learn from doing and that change their own parameters as they go along. So, but this is where we're interested in the development of this system. This could be, in a sense, this could be us building the system. That's also the becoming part in system analysis. We could be interested in the history of the system. How did it get to where it was? which is something you do if you, for example, analyze your Git logs. So we tend to over-focus, as I said, on structural modeling. We look for things. Maybe you've applied this. This is probably one of the things you learned in school about object-oriented programming, a heuristic called find the nouns, which tells, just look for the nouns and turn those into objects in your system. There's nothing wrong with that, but it's a very incomplete way of looking at this system. It's not just a bunch of things. It's not just a bunch of nouns and some relations between these things. That's structure, right? So you probably know these kind of entity relationship diagrams. They are a model, but I would argue they're not a very useful model because they don't tell us how the system behaves. Maybe there are some methods written on there that hopefully express some of this behavior. But it's still, this is scary if you talk to business people. Well, it would probably look more like this in reality. But this is, I wouldn't call, this is a model, right? It's not, it's just one way of looking at a system. It describes how everything is connected, but it's not a very useful model. You can't really work with this. You're not going to put this on your desk and every day, oh, yes, right, oh, yeah, okay. Also, by the time you've printed it, probably it's already outdated. And somebody spent a lot of work on making that in Visio or one of these things. And they spent 2 weeks arranging this and moving all the lines. And then somebody comes in and, nobody's going to come in and say, oh, but that's wrong, that is wrong, and that is wrong. You need to change that because it looks so perfect. A lot of effort went into that. So this is sort of a side tip maybe. When you do make models, don't spend time on making them pretty. Make them, learn from it, throw them away. Throw away the model. I'm not kidding. So because the interesting thing is in the drawing, in the act of drawing, in the modeling. So I like to say the drawing is more important than the drawing. So if you have this, so the people who raise their hands, they know this. If you have this kind of discussions with other people in your team, there's some problem. Instead of typing away at your own computer, go to the whiteboard and start drawing, and you're discussing together. Because it's visual, people can comment on it, so you get a much faster feedback loop that you don't get from peer reviews, code reviews after you made a pull request. So I have an example. Who has heard of BDD, behavior-driven development? Have applied it, maybe? Okay. So, behavior-driven development is a way of, basically having conversations with the business, writing those down as scenarios, as stories, and then turning those into tests. And typically they look something like this. Well, this is sort of a straw man version of a BDD scenario, but this is kind of a structure that they typically have. As an actor in the system, as a user, in order to do these things, and then it's a bunch of given when then, given this state and given that state. So if you read this and try to be aware of your own mental process here. As a shopper, in order to buy stuff, given I have a product X with price €100, and then when I buy something or etc., or when I check out the basket. So you have a model in your head now, right? I assume you do. But now imagine that, so this was probably how somebody told us, we had a conversation and somebody wrote it down this way. Maybe it's a functional analyst, maybe you wrote it together with the client or with the domain expert. But if the story had been something like this, so what you probably have in your head is a model where this is a table or a record of products, and there's some field price in there. That's sort of all you got from this, but probably you even have more in your head because this is a well-known domain to you, so you probably already matched this mental model that you're building to an existing mental model you already had. But that's beside the point here. What if the story had been like this? As a shop owner instead of a buyer, in order to sell stuff, given I have a product X, and given that product is priced €100 in the pricing table. So a pricing table is not a database table. A pricing table is something that a shop owner uses in the physical world, in a brick and mortar shop. They could use it to walk around the shop and sort of decide on prices in one convenient document. Right? So it's a list of all the prices of all their products, maybe to make strategic decisions about prices and discounts, etc. But because of the way this story is phrased, if you had seen this one first before the other one, your mental model would have been maybe two tables, a table or two records or two objects in your system, or two classes. One is products and the other is pricing, and they probably have some kind of relationship, but it's a different model. Again, none of these models are right or wrong. It's just that the second model would have been more convenient maybe for this kind of problem, the other one for the other. It's very trivial. This is sort of the simplest example I could come up with. But I'm trying to show you that just by the way these stories are phrased, your brain is already sort of in a certain direction. It's already triggered to build your system in a certain way, which might be suboptimal because you don't know. You haven't explored all the opportunities, all the possibilities. So when people call this behavior-driven development, given some state, given some context, when I do this, then this should be the resulting state or context. It's still very structural. I call it pseudo-behavioral. It's structural in the sense that I'm describing the structure of the system. I have these things, these resources, these states. I do this, and now I have this other set of resources and states. It's very easy to lie with this kind of tests, because when you implement them, you can still start with a state that is impossible anyway, that should never be reached in your system. So what I'm trying to say is this: the way we tell these stories tend to impose a structural model. And we are to blame. This is not the fault of this business expert or this client. In fact, we have taught them to talk in this way. Greg Young calls this our industry's grandest failure. The idea that instead of us learning the language of the business, we have taught them how to speak our language. They say, I want a grid with records representing this thing. That's not how normal people talk. That's how we taught them to speak to us. They think that that's the only language we will understand. So we're sort of pushing our problems, our complexity to them. So here's another way that you could have written this story that I think is much better. So as a shopper, in order to buy stuff, given the shop owner has priced the product at €100. This is a very subtle difference, right? At least at this level. It's a very small nuance. But the idea here is that I'm not describing state. I'm not saying the product is a thing that has a price, or there's a product and there's a pricing table with a relationship. I'm not describing a structure. I'm only describing what happened. I'm describing real behavior. This is things that have happened. I'm describing the history of this shop, in a sense. Here, it's a very short history. It's just one thing that happened. Somebody put a price tag on something. But this should, in my experience, this kind of mindset, this sort of focus on behavior as opposed to structure, leads to much better models and much richer models. And I'm going to try to show that to you. So here I have a slightly more interesting example. It's still a very sort of reduced, simplified example of, but this comes from an actual client of mine. And so it's an online learning platform. People can buy into courses, and then they take the modules. They can have some interaction with the teacher, take some sort of tests, and then get grades on the individual modules, and eventually complete the entire course. Maybe even get some certificate for that. And this was working nice. They brought it into production. And 1 year into production, they started to get complaints from students. And they were saying, well, my grades have disappeared. I took this module, I took the test, I got a grade, and now it's gone. I can't see it anymore. I can't see it on the site. Of course, we could say this is a bug, and we go in and we try to fix the bug. But there's something deeper there. There's a lack of a good model, I would say. If instead of, so this is this is actually, I'm very specifically chose this way of describing the problem on this slide, this language, because that's how the developers at my client were explaining their domain to me. They weren't saying, pupils come on and they, the story I just told you. They were. This is sort of the first thing they tell me. So I asked them, okay, what is your domain about? What is your, what do you do? What's your business? And they said, well, teachers have multiple courses, each with multiple modules. Students have multiple courses. They were describing a structural relational model to me. They were not describing the actual problem, which is, I want to learn. I want to register and learn something, and get a degree and a certificate. So the kind of how do you analyze these problems? Well, there's a couple of very simple questions that help a lot to make the conversation about that behavior. So it's what changes, what kind of things change over time, and why does it change, and who does that change? Under what circumstances does this change happen, or does it not happen? How often does it change? The scale of things. If this happens, once a year, or is this something that happens 1,000,000 times a minute? I hear myself. So, and the most important question: what are the consequences of that change? It's not just something that changes. It's every change has some. Well, not everyone, but a lot of them have consequences. More stuff happens. We would call these processes. So, we could take the 3 B's and say becoming. How does the learning system become what it is? Well, because the teachers are adding and removing modules. This is behavior, right? So what happens to students who already completed some of the modules that are now obsolete? So we're basically asking, what is the consequence of adding a module? What is the consequence of removing a module? Now that we ask this question, suddenly it becomes very obvious what the problem was. They had a model that was a sort of relational model. They probably had some cascading deletes in there. And so, a student is in a course, took some modules, took some tests, got a grade. That teacher suddenly decides, well, I want to change this course and remove this module and maybe make a new one. And nobody had thought of what happens, when somebody does that. So it was a very sort of, database-centric model. It's a bunch of resources, it's structure. I can remove things from that structure, but nobody had considered the consequences of doing so. So that's sort of where the bug was, of course. And the easy answer is just fix it so that when a module is removed, the grade is still there. But there's an underlying model lacking for this. So there's another way of building systems that is becoming more and more popular. Maybe you've heard of it. It's called event sourcing. It's another way of, fundamentally, it's another way of doing persistence. Instead of storing the state of the system, as we tend to do in a relational database, we store all the state changes. We store all the events that happened over time. And if we want to see the state of the system, if we want to see the artifact, then we can just project these events and build up this state, right? So we can just replay all these events, do some calculation, and we have the current state of the system. I'm not going to go into detail today of how you build these kind of systems and how you implement them and why they can be very performant, because maybe you're thinking, seeing this picture, this must be a very slow system that just eats up disk space and continuously needs to recalculate stuff. The short answer is, of course, that everything can be cached. But it's very interesting. If you're interested in event sourcing, definitely look it up. But so what happened is that, so this stream of events, it's a history. It's an append-only immutable data store with all the events that ever happened. So you have a complete history of your system, so you can calculate any kind of state that you want. So what happened is that people started building these kinds of event source systems. Well, Greg Young, who I already mentioned, I think he was here last year, wasn't he? I picked that up somewhere. And he used to build this, or he started building this for high-frequency trading kind of systems, etc. And started writing about it, and other people started picking it up. But something else grew from that. And so this is sort of a technical thing, event sourcing. How do you build a system? But people started, people like Alberto Brandolini and Marco Heimshoff and myself and some others, we started trying to come up with visualizations for this. So and this is what we did yesterday as well with the core team. So event storming is a way of visualizing events happening over time. It's fundamentally a timeline. It's as simple as that, right? So it's a model, it's a visual model, but instead of thinking about what things do we have here, we simply keep asking the question, what happened? What happens that is interesting to the business? What happens before? What happened after? How did we get here? What process follows from this? The questions I was showing earlier. What changes? What are the consequences? So going back to this example of the students and the online courses, if you model a problem like that using event storming, it would look something like, a teacher deletes so maybe a student takes a course, student takes a test, gets a grade, teacher deletes a module, and now you can see this. This is a bunch of things happening over time, and you can ask, okay, given this has happened, what are the consequences now? And the consequence, of course, this could be something that you have to discuss with the client or with the domain expert. What do you want to happen in this case? Do you want to delete the students' grades? Do you want to transfer these grades somewhere else? Do you want to keep a student on the current version of the course that they subscribed for, and only new students get the new version of the course? You can visualize these things and you can play around with it. And it's very cheap and easy. It's just like moving Post-its around. This is like the cheapest part. Whether it's event storming or some kind of visual modeling, this is the cheapest part in the entire software development process. After that, it just gets more expensive. And if you make mistakes, it gets even more expensive. Here, if you make a mistake, just throw away the Post-it. So how does this work? Right. This is what it looks like at the end, typically. Usually this could be like 2 hours work, 3 hours work, so never hire me for a consulting session if you don't want your office to be plastered with Post-its. So you need sort of this very large modeling surface, because if it's small, you're going to get stuck. You're going to start modeling, and as soon as your surface is full, you're going to stop modeling. People do this at a whiteboard. They're drawing, and as soon as it's full, they keep talking, but they stop drawing. So don't allow your logical solution to be constrained by your physical modeling space. This is why I bring the large rolls of paper and fill all the walls. So we can start very simple. Find some event. I drew it as a little envelope because it is essentially a message, but that's not very important here. It's just an event. It's something that has happened in the past that is interesting to the business. Invoice was paid, I'm again taking the simplest examples I can find. Invoice was paid is an event. It's even in the language of the business. It's not payment event or invoice event or something like that. It's just natural language. Invoice was paid. If I implement this in my code, the class name representing this message will be called invoice was paid. Right? So this is our first event. And then we can ask ourselves, what led to that? What caused this to happen? Right? So it's, again, it's a timeline. So now we can take another color and start looking for commands. So an event is something that has happened. It's in the past now. We can't change the past. We accept it as fact. But a command it's also a message, but this time it's a message that somebody sends to the system, trying to make the system do something. Right? So it's something that causes state to change. If you think about this in terms of HTTP, this would be a post or a put or a delete. So this could be a command, somebody telling the system, pay for this invoice. If it's some sort of, again, it's a very simple model. In reality, it would probably be some amount that is on a bank account, deposited on a bank account somewhere. We have to match that payment to our invoices in our system, etc. So in reality, it would probably be more complex than this. But depending on how involved you want your invoicing application to be. In fact, I worked for a debt collection agency, and they had a huge model for things like invoices. But so we pay for invoice, and then we can ask ourselves, when we have this command, so this is somebody asking the system to do something, but this might fail. This might fail for technical reasons, of course, database connection lost, but we don't care about that here. We're modeling processes in the business. But it could fail for some reason, and that reason is a business rule. What could the business rule here be? Well, something as simple as the paid amount should be equal to the invoice amount. If it's not equal, this invoice isn't paid. Again, we could have a conversation with the business. Does this, when we get a payment amount that is smaller than the invoice amount, do we simply refuse that payment? In this case, probably not. But you can imagine lots of business rules where there's a lot of variation in what you want the outcome to be. But so here we're saying that this is actually causing a branch in our process. There's now two directions that our process can go. Either the invoice is paid, the amount is equal, or the invoice is only partially paid because the amount was too small. And this starts some other process. Right? The following process there could be something like sending a reminder or trying to get the rest of this amount. So when I'm event storming, it's always first focused on the events. It's trying to find all the things that happened that we're interested in. Second is finding these commands. So usually it's not just one little thing like this, but sort of starting large, trying to discover the entire system, and then zooming into smaller things. Especially when we get to actually building stuff, then we zoom in and we try to model these sort of small processes. But this is sort of the general pattern. There's a command, which is typically a user trying to do something, which could be as simple as filling in a form and clicking a button. There are some business rules, constraints, invariants that determine, do we accept this command and what are the consequences of this command. And then the consequences, the outcomes are expressed as domain events. And by doing this very explicitly, so this is already a model that expresses more than just structure. Well, it doesn't express structure at all. It doesn't say anything about what my invoice object looks like. It tells me what the events are that happen to invoices. And it tells me the business rules, which are very critical. This is sort of why we built software, because there's a whole bunch of processes, at least sort of line of business applications. There's a whole bunch of processes that can have very complex business rules that we don't want the users to have to remember, or that we don't even trust the users to do correctly, that we model. So why don't we put them on our UML diagrams? They are the important thing. And by writing them out, especially writing them out in, well, I would say somewhat pseudo-mathematical notation here, you can already see if you have, you should already see that there's something missing here, right? So simply by forcing ourselves to write out business rules, we will already discover stuff, questions that we may not have thought of, asking the domain experts. So of course there's a third case where the amount that we're being paid is too large. Maybe this never happens, maybe this happens all the time. But this was in fact, if it was not a bug, at least it was sort of undefined behavior in our system before, where we had no idea what would happen when somebody paid too much. Maybe we couldn't even match the payment and this would be orphaned, and then we would send reminders and they would be very unhappy because they already paid. But now we have made it very explicit in a very cheap and easy way that business can understand. So, and this approach tends to scale very well for very complex problems, even with non-technical. This is programming with non-programmers. This is a switch case, right? You have given somebody a marker and some colored post-its, and they're programming the system for you. So, well, I like to annotate these models with some more details. For example, this little symbol here represents that when the invoice was paid, the process is done as far as we're concerned. So just to demarcate processes and see where they start and where they end. So this one ends. The other two, of course, don't end because we still have this partial payment, or we have too much money and we need to somehow give it back. So the next thing I look for is how does knowledge work in this system? A business rule is a decision point. It has some knowledge about the past of the system and makes a decision about what happens next. That's as simple a description as I can give. That's what a business rule is. So if it has knowledge about the past, and we have a temporal model anyway, we could start looking for how does this business rule, what does it need to know to make its decisions? So first of all, of course, it needs to have some, it needs to know the command. If I send a command with the payment amount in it, the invoice amount is not in there because, well, we can assume that this command can be spoofed. It's an HTTP request, for example. If I could put in the invoice amount and the payment amount, then I could set the invoice amount to 1 and the payment amount to 1, and then I have paid very cheaply and cheated the system. So the payment amount is not in there. That comes from somewhere else. So the question is again, what happened before? And before that invoice can be paid, it has to be, this customer was invoiced, for example. So this invoice somehow needs to be created in our system. Maybe it's generated, maybe it's made manually. But there's some place where this system, where this invoice comes into existence. So now we can see there's 2 arrows going back for that business rule. To make a decision, the business rule needs to know about the payment amount, which is in the command, and the invoice amount, which is in the event that happened before. And then, of course, we can ask what happened before, and there's probably another command saying invoice customer. So again, pay attention to the language here. I'm not saying invoice was created, which is not. This is a database language. This is CRUD language. In domain-driven design, we look for the language of the domain, the language that the people would speak in this, who work in this business, and they would say the customer was invoiced. They wouldn't say we created. Again, this is sort of moving away from very structural language. We have things that are created and changed and deleted, or edited and deleted, but moving to a language that expresses why we do this. In your domain, in content management, it's from sort of the structural way to describe it would be say the article status has changed to published, but that's not what we do. I mean, that's not what the business wants to do. They want to publish an article, right? The article was published, not the status was changed, which is a very technical way of describing this. So we try to get this language in our models, this language from the domain, get this language in our models, in our code, in our documentation, in our tests. In fact, in domain-driven design, we call this idea of using that same language everywhere. We call it ubiquitous language. I love saying that, ubiquitous language. So this is sort of what happens before, and I had another mark here to say this is probably the beginning of this process. Of course, there may be other processes that happened before. Maybe there was an ordering process and a fulfillment process, and somehow we need to get this product or these services to this customer. But we can still sort of see this as an individual separate process with maybe some transfer point. And now we can ask what happens after, right? Because we had on top here, here we have the invoice was overpaid. So probably some process follows where we either reimburse this money or book it onto the next invoice, or maybe send them a discount code to make up for it, some way of making up for the mistake. And here we have a partial payment. So once again, we need to, probably the next thing that happens, well, ignoring the whole sending reminders, etc. But the next command here, the next blue thing, is again pay for invoice. And again, we have a business rule. And again, we have 3 possible outcomes where now the invoice is fully paid. Maybe this was 50 euros and this was 50 euros, and the invoice here was 100 euros, so now it's fully paid. Or maybe it's still not enough and it's still partially paid. Or maybe this time they paid too much and it's overpaid now. So this process is repeating. But what I like to do when I'm doing these timelines, this event storming, imagine these are just post-its. I like to have this repetition very explicitly. As developers, we always try to be very dry. Don't repeat yourself. I already drew this, so I'm just going to draw an arrow saying this repeats. But sometimes making that repetition very explicit and doing it twice or even 3 times can show you something, can learn you something about, does this system actually behave the same way if it's doing it once or if it's doing it multiple times? And what changes and what are the consequences and who does it change and how does it affect things? So again, very trivial example, but there's a slight difference in how we would describe this, this business rule now. Remember here we said the payment amount from the command needs to equal the invoice amount from the event. Now that's not entirely true. If we draw the arrows, it's not just 2 arrows, it's an arrow back here as well. So it's not just the invoice amount itself and the first payment, it's also the next payment, right? So we need to rephrase this business rule. It's very subtle, but it's not just the paid amount, but it's the sum of paid amounts that needs to equal the invoice amount. You probably would have discovered this when you wrote this, even if you don't model or anything, if you just do this in code. But what I'm trying to show is that by making business rules very explicit and modeling them and making them part of what you explore and how you ask questions to the domain expert and figuring out the consequences and figuring out how a certain decision gets the knowledge it needs to make a decision, gets the data it needs to make a decision, you discover this kind of stuff you never thought about, and that comes up, 1 year into production when your student starts complaining that their grades are disappearing. So I think it's very valuable to try these techniques. There's more happening, of course. For example, here there could be 2 outcomes because this one here was invoices partially paid. And now we have, in fact, another partial payment here. So there's another invoice was partially paid, but the combination of these 2 is actually another event saying the invoice was fully paid. Why is this interesting? Of course, some system that is listening to these events. Maybe you put these events on a message bus somewhere and there's some other system or some other service listening to these events. It could listen to both of these, of course. Every time there's a partial payment, keep that intermediate state and then add it up and then decide, okay, now it's fully paid. But then you're really duplicating the logic of this business rule in that other thing that is also listening to these events. Whereas here, the decision is reflected in another event saying fully paid. So some systems might be only interested in invoices that are fully paid. Maybe we can only ship the product if it's fully paid. So some system might listen to every time a fully paid event comes in, I do this other thing. And some other system might be very interested in these partial paid events because it wants to, for example, it wants to analyze the payment behavior of our customers. And this is the kind of thing that we built when I was working for the debt collection company. Although we didn't do it, that was in like 2011, and we didn't do it in event sourcing yet. But so what we have done now is we have built an entirely new set of visualizations, new primitives for making our model. This is what we had, artifacts, structures, objects, or records or tables, and then some relations between it. And then maybe if we're lucky, some behavior written on that map. But usually by the time you get there, you have spent a lot of time on drawing these things in Visio. What we have done, just with post-its and markers and some paper, is these primitives. There's time, first of all, so we see history, not just facts at one point in time, but the history of the system. We see these, I call them knowledge dependencies, these arrows going back from business rules that show us how things are connected, how a business rule needs to make its decision. Why is that interesting? Because we can now sort of see things that cluster together. If some business rules have a lot of arrows going back to some events, they will cluster together, they belong together. They are maybe something that we need to model as one cohesive whole, as one conceptual thing. Right? Whereas if there's 2 processes and there's no arrows connecting them, there are probably 2 things. Just the sort of how the model looks and where the lines are gives us a clue of what could be a good implementation at this point. So we have the constraints, or business rules, or invariants, whatever you want to call them. We have the history, we have intentions. Somebody wants to do that. You can think of those, so the commands in blue, you can think of those as use cases even. These are the things I allow people to do with this system. Instead of saying, here's a huge form with every possible field, and you can change all of them, we're saying very specific things. In your domain, it could be, instead of we change the publication date, You could say we're allowing them to schedule the publication. You know, it's not just changing a field, but it's changing some conceptual whole, and scheduling could mean changing the start date for the publication and the end date, and maybe when this thing is featured on the front page and when it's not. And so this is a conceptual thing. We allow people to do these things, so we can express these as commands, and these commands have names that come from the business, and it all starts to fit really nice together, especially if you combine this visual modeling style with something like event sourcing in your implementation. But even without, this helps you to find better objects. And then, of course, we have sort of processes, and you can see that this stuff clusters together. I only had one now, but if you fill the wall, you will see these sort of clusters. There's more stuff you can put the people on there, who's doing what, and queries and state, etc. But let's not go there. So, just to reinforce this point, it's not the one true model. It's just one way of looking at the system, a temporal model, a behavioral model, versus a static or structural model. But I think it was worth repeating that point. We have a little bit of time left. So there's more you can do with this. You know, there's a lot of these processes where we can, in fact, by drawing these arrows, we start to see a certain structure. I left out the commands and the business rules here, but just imagine they are there. So instead of saying it's one huge process, it could be two processes with some kind of artifact in the middle. And this artifact is typically the thing that transfers from one business process to another. It's the end of one process, and at the same time, this artifact represents the start of the other process. So that artifact could be the actual invoice document. You know, an invoice is a message where you say, my process of building an invoice is finished. I hand this artifact to my customer, and now the process starts of invoicing, of getting that invoice paid, you know, debt collection. Could be a receipt in a warehouse, could be a contract. So we call these two phases collaborative construction, or planning, you will sometimes hear, and execution. So it's collaborative construction. Maybe it's not really collaborative and it's just one person, but very often they are complex things where different people are building the invoice together. Maybe the salesperson needs to add the products, and maybe the account manager needs to add some details, and maybe somebody in charge of products needs to add the prices. And then this invoice is done. It's maybe even signed off by somebody, some manager. And this artifact is now the start of the next process. It prescribes how the next process goes. You know, this invoice contains the information that decides we expect you to pay us this amount by this date. You know, it's a prescription of a process. So, well, this is the example I just described. So we could, instead of building one huge invoice object that is this massive God class, we can build three smaller objects. One object that represents this process of drafting the invoice. One object that represents the actual invoice, just sort of the state, you know, the thing, the document. And then the process of invoicing itself, where we send it. So the first event is probably invoice was sent to customer. Maybe we get a payment, or maybe we get maybe they contest the invoice. Maybe we send reminders. Maybe it's a long process with lawyers, etc. And in the end, hopefully, the invoice gets paid. Same thing for our example with the online courses. We can split this up in two processes. One is course design, where the teachers are building the course. Then the course itself is just the artifact. We can separate that into a separate object. And then the students taking courses is a different object. We use a different model for this. I'm saying object, but it could be a set of objects or a set of models. So we can build smaller, more focused models that have their own rules and their own constraints, because the sort of constraints that apply to the concept of what a course is while you're building it are different from the concepts and behavior that applies when you're taking the course. So why build one huge object for that? So this is how, even if you don't build event source systems in object-oriented systems, you still get a benefit from looking at these at processes as opposed to structure. You will find more focused, sort of single responsibility object. This object here is only responsible for helping teachers build this thing. it doesn't represent the actual thing. When this process is done, we create the actual thing. This may look like redundancy, and well, theoretically it is. We are copying information from this process in this artifact, but that's fine. I mean, redundancy or excessive normalization is overrated anyway. In fact, I would argue that normalization is how they got into the problem with the disappearing grades in the first place. So this is the same for warehouse management. There's maybe some ordering process, and then at some point, it's very simplified here, but a truck driver comes, they have products that they're unloading. At the same time, some receiving operator it's called, has this receipt that lists all the products in that, all the stock in that shipment. And, okay, 5 of those, 10 of those. Oh, there should be 5 of those, but there's none. So that's the receiving process. It's comparing the actuals versus the plant. And then put away is moving it into the warehouse, putting it at the right place. So same kind of, again, this is not just 3 objects. This would be 3 entirely, or 4 probably models. Insurance, again, collaborative construction. You're building a contract. Maybe if you are just a private consumer, the negotiation process with an insurance company is usually very short because they just fill in some of the basic fields and you get the same contract. Everybody gets sort of the same contract. But if you are a very large client, this process could involve, could take weeks or months. And the contract is just the artifact. It's just a description of the things that you agreed to in this process. And then maybe years later, somebody files a claim, and now the contract prescribes how this claim proceeds. Right? So these patterns, there's another phase. I'm not going to go into detail, but we can sort of track everything that happens here. And we have it for free, because if we do event sourcing, we've stored all these events in our history. So we can do analysis on that, and then use that to improve our processes again. So this is stuff that businesses do, of course, but they usually don't think about it as these sort of nicely separated processes. So 3 archetypes: collaborative construction, execution, and then analysis. Once you see them, you start seeing them everywhere. Any kind of, well, not all business processes, but many business processes actually fit in this pattern. And even what you do, software development, you build the artifact collaboratively in Git, and then at some points you make an artifact which is the code base, the build, right? And this thing you deploy, and that's when execution starts. Literally, you execute this thing. The code prescribes how the system will behave at runtime. And then we do monitoring and analysis and looking at logs, discover bugs, and etc., and then feed back into the process. This gets a little bit more advanced now, but I still want to show this, and then I'll skip the rest of the presentation, because this is why it's so powerful to model with time. Because we can now start seeing how, by visualizing this with post-its and just making timelines, we can start drawing lines of how one process affects what happens in another process while it is running, while it is happening. Sometimes nothing, but sometimes it can be very implicit. In this case, invoice or debt collection, the invoice goes overdue. There's some implicit agreement, maybe just an email from the CFO saying, from now on, we need some money quick, so call debtors, people with invoices that are outstanding, call them after 3 days. That's just an implicit policy. But if you make a more advanced system, you could actually program that into the system, or hard-code it, or configure it, where it shows you after 3 days, it shows you a notification, call this person because their invoice is 3 days overdue. So that could be a sort of fixed, coded policy, where the system tells you what to do next. And maybe just a little bit more, maybe it's call after 3 days, call again after 10 days, send an angry letter after 15 days, send a lawyer after 30 days. That could be the process. But then if you start building a SaaS debt collection thing for many companies, they all want their own version of it. And they don't just want their own version, they want to, again, learn from from the payment behavior of their clients and start adapting this over time. So the policy changes over time. Changing the policy becomes its own process here. And it could be very involved where, if they're very big clients, maybe we make it slower and we do more friendly phone calls. Or if it's, our most important client, maybe only the CFO gets to do a phone call and, be very smooth and friendly and talk about the weather and football. And then, oh, by the way, this invoice, can you look into it? But of course, you're not going to do this approach for if you have thousands of very small invoices. So we can start having a process that over time changes the configuration of how these invoicing processes need to go. And we can start modeling that. We can start visualizing what if we have some ongoing process here and we have changes in this process, we change the configuration. How does the change in, configuration, I prefer the word policy. What if the change in policy, should it affect the ongoing processes? So it could be that there's nothing. So this is sort of, this could be a simple solution here for the course problem, where we simply say that it doesn't affect it. Meaning, when I'm in a course, I stay in that version of the course until I finish it. Even if the course changes entirely, I'm still doing the old version. But now we can ask the business. If you ask the business right after you have drawn this sort of picture, they can form a mental model of it that is, very visual. That is very. You can explain the problem. You can discover the problem and explain the problem, and visualize possible solutions, which I don't think you can with sort of traditional modeling styles, or with just conversation. Even would be very hard. So this probably wouldn't happen in a warehouse, because this process of receiving, where the truck comes in and we have to unload it and check it off and put it in the shelves, that takes maybe half an hour or an hour. If during that time somebody says we're changing our process, that's probably not going to affect things, but it could be, and it could be things like the things that are decided here is, for example. Certain types of products need to go into certain areas because maybe they're high-value products like iPhones. You don't put your iPhones just anywhere in the warehouse. You put them in a closed-off area, and only certain people have access to that. You don't allow your day-to-day hired workers to touch those. Only your fixed employees. Or it could be things like, what if we get damaged goods? Do we give them back, or do we store them, or do we store them separately and then sell them to sort of low-cost, low-budget supermarkets where they buy slightly damaged stuff and resell it, etc. And of course, it gets more interesting if you have. So that was a very short process here, but with insurance claims, if this takes years and this takes weeks or months, what if your insurance products change over time? What if your anti-fraud strategy changes? How does this affect ongoing process? You can start modeling these things. And I actually did this with a life insurance company. They were very happy to finally sort of have a way of visualizing these things, because this is a huge problem. This is a regulation problem as well. You can't just simply change your insurance product and all your clients suddenly have to simply accept this. We can ask them for permission, but sometimes it's a lot more involved. So I wanted to show that, just to show that by making timelines and looking at behavior, you can make much deeper visualizations and have much more interesting discussions about very complex cases that you can't have that I don't know any other way to do, really. Even if your domain is not as complex as life insurance, I think it's a very valid tool to use. I'm sort of out of time. I have some stuff about implementation and versioning and how to push these policies into the process, etc. But I'm going to skip that. But the slides are on my website if you're interested. So, but this is the main point, right? If you have a complex or even just a fairly simple business process, try looking at it with a temporal model. And if you do a presentation about time, you cannot omit quotes by Einstein. So Here it is. The only reason for time is so that everything doesn't happen at once. Thank you very much. If you have questions, we have a couple of minutes, I think. Nobody? Okay. Marco?
So at the beginning in the PDP approach that you proposed, where you move from state-given expression, sorry. When you move from state-driven given clauses to execution of previous steps, how do you actually run these specifications? Because that's actually what we do practically when you have something like an auction and you want to publish that auction, but the publishing date cannot be in the past.
So are you asking about what if my test is coupled to time?
Yeah.
Well, there's a simple solution for that, which is called a system clock. Instead of depending on something like date time in PHP directly, so never do that. Just depend on something you call clock or even time machine. And this can be an object that you inject in all the objects that need time. For example, just through dependency injection. And then instead of saying new date time now, you can say system clock get now or get current time or something. And then you get a date time object. But now you can mock it and you can play around with time. So even without event sourcing or anything, that's possible. With event sourcing, you have some more possibilities because you can now model the passage of time as events themselves, as discrete events. So it could be something like a day has passed is a concrete event. So now I can write a test that says, given I send an invoice, or given customer was invoiced, and given day has passed, and given day has passed, and you do this 30 times, then I want a reminder to be sent, or then the invoice became overdue. You can write a test that actually just describes the progress of time as part of the test. So it's very easy to test, in fact. I actually write this on the post-its when I model this thing. So this happens, and then plus 30 days, for example, the invoice becomes overdue. We're taking time into account. Was that what you're looking for? Or? Okay. Any other? This is a very short answer, but any other questions? Okay. Thank you very much for listening. So slides are on the website, some blog posts. I teach workshops. I'm also the organizer of Domain-Driven Design Europe conference in Amsterdam, end of January, beginning of February. So if you're interested, check it out. Thanks.
All right, thank you, Matthias, for providing this knowledge and this insight into the topic. Thank you for sharing that with us. So next up, we are going to have a next highlight talk by Marco Pivetta about extreme defense PHP, which starts in 15 minutes. And in parallel to that, there is the preparation workshop in room number 7, that's right behind you, for the certification tomorrow, just in case if you want to participate in the certification tomorrow, that might be helpful to get there, to get some more information. If you're not participating in the certification, then we will see here again in 15 minutes and listening to Marco's talk.
Just lift me up from here. I said I wonder where I go when I leave this crazy place. Where will my soul reside? Will I find happiness? Where will I go? Just lift me up from here. Where will I go? Just lift me up from here. Just lift me up from here. I said I where did yesterday go? Where will tomorrow be? Angel, shine your light on me. Shine your light on me. Just lift me up from here. I said I wonder where I go when I leave this crazy place. Where will my soul reside? Will I find happiness? Where will I go? Just lift me up from here. Oh, where will I go? Just lift me up from here.
Passt schon nicht, passt schon.
So, we can continue now with Marco talking about extremely defensive PHP. I'm curious to hear about that.
All right. So, all right. Hello, everyone. It's nice to be here. I didn't know there was a Typo 3 conference in Germany, but I've moved here recently. I'm Marco. I live in Frankfurt. Ich rede Deutsch, but this talk is in English. So, if you don't know my name, this is my nickname on the internet. My primary job is trolling, and as a secondary job, sometimes I'm a consultant. So this is the avatar for those who don't recognize it. I recently patched it up, so since I do very, very horrible things with PHP, they started calling me Gandalf PHP, so I had to upgrade it. Why is that bar showing out on the left? Oh, Ubuntu. Oh, well, whatever, we'll go with Ubuntu, whatever it does. Anyway, so I work for a company called Rove. We are Zen Framework consultants, and we handle stuff in Doctrine. I'm part of the Zen Framework team, and I'm part of the Doctrine team. So this means that I'm pretty much the bottleneck if you don't see releases. Sorry about that. But today we're not talking about these tools. We're not talking about specific frameworks. What I want to talk about is generally PHP. So hands up, who here is not a developer? All right, so there's a couple people. I hope everyone else does PHP, right? Typo 3 is PHP, right? Yeah? It's all right. It's not all TypoScript. Anyway, so we're talking about extremely defensive PHP. Now, extremely defensive PHP, the title is not, you don't need to be scared of it, but I became an extremist when it comes to code.
I don't really take middle ground anymore, and that's because I'm sick of it. So I became an extremist, and the problem is that I write a lot of code, I review a lot of code, and I fix a lot of code. And every day I put something like 20 to 200 answers on GitHub about somebody stuck with something. So, you know, it kind of forges you. I do way too many projects, and all of these projects do way too much for what they should do. So this means that pretty much everyone that comes into your project goes into the issue tracker and posts a new issue. Why does your project not do also X? Why doesn't it do Y, and so on? And this is very common. It's just because we want stuff, okay? We want it, and it needs to work, regardless if paid or not, we want more. That is pretty much the representation of what is called the feature creep. But so generally, I'm going to talk about aggressive principles, so you don't need to apply them to all your projects. Especially if you're doing agency work, I know that you just want to release a website quick, and it doesn't need to be all perfect. But if you're dealing with money, transactions, stuff that can break, stuff where people can die if you make a mistake, please be careful. If you do open source, you don't know where your software is going to land in, so probably one of those scenarios will happen to be true. So these practices work for very long-lived projects. They don't work for that project which is just a landing page that needs to live for a couple of weeks, but they are necessary for projects that are supposed to live a very, very long life. And every open source project does that, okay? Anybody heard of LeftPod? Right? No, never mind. I don't want to know to pick on the Node.js developers. We did these mistakes as well. So please know your limits. This is not for everyone. If you don't like these practices, don't apply them, but I don't see a reason not to do that except pressure on time at the cost of taking off responsibility, right? So be very considerate about what you publish out there. Not everything that you type on your computer needs to go on the internet, okay? You don't do that with your Facebook stuff. You don't do that with your private pictures. Don't do that with your private software. There is no need for it. So let's start in a bold way. You are dumb. Oh, no, sorry, wrong slide. I don't mean you. Sorry. I am dumb, okay? Everyone is dumb here. Everyone is dumb. And that is because we are still animals. We have a brain which has a limited computing capacity, a limited scope of what happens. Every person can keep in mind at most seven things at the same time, and not very well. Okay, if you have 7 things to keep track of at the same moment, you're gonna freak out. That is your physical limit. And you're going to make a lot of mistakes. And this happens when you have to consider a project, things that happen inside your project. You have to consider a lot of scenarios and things that may go wrong, and forking of processes and stuff like that, and it's gonna be really complicated to track all of that. So you are dumb in a context of knowing all this stuff. You are a tiny entity that can't keep track of all of this. If you think that you know everything, right, then you're probably the dumbest here. If you think, I know how this stuff works, I know how to track all this, and it just works, then you are probably the dumbest here. So, does anybody know about defensive driving? Any BMW drivers? Just kidding. So, defensive driving is pretty much the idea that you are not the only person that is going to make a mistake. The truck driver in the highway is going to go to the left driving lane while you are surpassing them, and a kid is going to cross the street right after a house so you can't see them. Somebody brakes immediately, and so on. So you assume that somebody else is going to make a mistake. You're not a perfect, maybe you are driving in a perfect way, but somebody else is going to cause some trouble. So you can't assume that everything is perfect just because you are doing everything right. There is going to be some problem somewhere. Defensive coding is pretty much like defensive driving, and the problem is that you have to be cautious about everyone's code. And this includes yourself, includes yourself yesterday and includes yourself tomorrow, because these are different people, okay? I don't remember the code that I wrote yesterday. I don't even remember what I was looking at yesterday. Okay, so every day you improve, you change your way of thinking, you code in a different way. If you look at your code of 2 years ago, probably it looks very different from what you did today or yesterday, okay? And you have to be very cautious about what you wrote in that date and what your code can do to future yourself or to somebody else. So be very cautious about what you write in first stance. So let's grab some references. I'm a bit abstract here, I realize that, but we are going to go into more practical scenarios soon. So some references, books that I suggest, and all the stuff I'm talking about is not new. This stuff has been around for ages, and there's been a crisis in software development in the 70s, in the 1970s, where they tried to figure out how to make software better. I mean, software is not recent, okay? So this stuff was researched before I came here and talk about it. So there's Code Complete 2. This is a bit of an outdated book, in my opinion, because it suggests stuff like don't make a method or a function longer than 50 lines. I'm like, don't make them longer than 5 lines, just to give you an idea. But it still includes some useful suggestions about how you should structure your code so that it actually looks like usable code and you are going to understand what is going on. The other book that actually forged my career is this one, which doesn't work here. Okay, this is going to happen 5 times during the presentation, I think. So, it doesn't reboot. Good. So this book, called Effective Java. Now, I'm not a Java developer. I just learned some Java. I did some Java applications for fun. But this book is basically a manual of how to build bugs into Java. Okay, this book is full of bugs that you can build yourself in Java, like file access, concurrency, shared memory, null pointers, whatever, you name it, it's in here. Okay, so this book is going to tell you how to break a system and what you did wrong to break it. So I highly suggest that book. Another thing that I want to introduce is a concept which is called poka-yoke. Anybody ever heard of this? Couple hands up, okay. So poka-yoke is Japanese, and I hope nobody knows Japanese here, so I'm going to just lie about it. But the idea is that it means avoiding mistakes, and it means also foolproofing. When you have a factory plant, and you have a machine, and you need to put screws into a washing machine, for example, okay, then it must be very, very hard for the person assembling this machine to put the screw in the wrong location. So it must be already turned in the right direction, there must be one only location where he can put that screw, and so on. This applies also to Lego. Okay, you can't put 2 Lego pieces upside down and put them together, there is one direction, and so on and so forth. To give you a better practical example, you know what this is, right? This is an RJ45 cable. Anybody ever managed to plug them in upside down here? I had conferences where somebody raised a hand, so. Or people that say that they made an ether killer. Don't do that. I hope there's no sysadmin here. But anyway, the point is that there is only way of plugging this in. And this is what the concept of poka-yoke is. Okay, there is only way of using it. You can't do it wrong. I mean, it's really, really hard to make it wrong, unless you use a hammer or something. On the other side, to give you a counterexample, this is a device that exists in a 4-dimensional space. So you plug it in, doesn't work. Turn it around, plug it in, doesn't work. So now you turn it around again, and then there is some kind of time lock warp opening, and now it suddenly works. So this is maybe not such a good example of poka-yoke. On the other side, I must say that it's really, really hard to break this. So at least that got done right. Okay, other concepts to make clear. Code is reusable. Yeah, right? Seems reasonable, right? All right, code is not reusable. Once you take a concept that you have in your brain and put it into code, it is substandard already. You had this idea in your brain that is your ideal world of how it should work. Once you wrote it in code, it's buggy automatically. It is going to have bugs mathematically. Code is not reusable. Code is crap, like 90% of everything. This is a theorem about literature. So 90% of all literature is crap. So is code. If your code is not crap now, it is going to be crap in 5 years because standards change. Abstractions are reusable. Abstractions are concepts, things that you can use. In our world of object-oriented programming, abstractions are what we call interfaces, okay? Pretty much. So when you share code with other people, share the abstraction first, and the code needs to be replaceable in every moment. So don't write crap, don't write code in first place. If you don't need to write a piece of code, don't write it. Is there a reason for that code to exist? No? Then don't write it. All right? This thing keeps breaking, so. All right. So what you need to do is you need to first code only for what you need to solve. You have a problem, solve it with code. Don't invent a problem and then solve it. That's what engineers do, okay? And arguably, it's like a big waste of time, and that's why the industry still keeps doing money, at least from our side, from the part of the business. I hope they'll never figure out that. But don't code for your reuse case. You are designing your code to fix a problem. Don't code for something that will come up in 20, 30 years. That is not what you're solving. That is what Matthias was telling you. You're building an abstraction that needs to solve a problem. You're not building an abstraction that is supposed to solve every problem in the world. This is not what you want to do. When you build a video game, for example, there is this golden rule that I learned from Sean McCool, and he said, I don't know where he got this rule, but he said, if it looks right, it is right. Okay, that is really, really interesting. Because when I started coding, I was like, oh yeah, let's build a physical model of particles and stuff and see how we can build a video game of that. No, it's like movies, where you have these buildings and you go back and there's just a piece of wood keeping it up. There is no building, it just looks like a building. Okay, that's a good abstraction. Okay, let's go to good practices here. Let's go to practical code. So, I'm going to assume you write solid code. It's a big assumption. If you don't know solid principles, for which, to be honest, I never remember the acronym anyway, you should at least look them up. Another thing that I'm going to assume, which is a big assumption as well, is that you have some knowledge about object calisthenics. How many do not know about this word? Okay. There are talks about it, and this is a link eventually. So you'll get the slides, there is a link there. Anyway, so I'm going to assume that this is known. These are practices that you should at least read and learn. You want to make at least most of your system as immutable as possible. So what you do is, whenever you have a concept of something in your system that is just a value that is passed around, just model it in such a way that that value can never change. If it is an interest rate object, you just wrap it into a tiny object and make sure that nobody can change those values inside those objects. By reducing immutability, you pretty much reduce all the bugs that have to do with the change of a value during time. That is pretty much what most bugs that we work on are related with. So you pretty much every time you look for a bug, it's always some kind of flag that changed over time, and then you need the debugger to hook in, and then you inspect that value because you don't know how it was there and what happened after that function call and so on. Value changes are pretty much often caused by side effects, and it's a really big mess to debug them. There is a good example of how this got solved. I wouldn't say perfectly, because it's not really immutable, but it's mostly mutable. PSR7, anybody using it or heard of it? Yeah? Heard of it? Come on. Well, PSR7 is pretty much this HTTP abstraction that is proposed by the Framework Interop group, of which, to be honest, Typo 3 is part of as well. So You got a bit of a performance overhead in this, because every time you want to change a value, you create a new object, and the previous one gets garbage collected. And this may cause some problems, especially in a language that is not compiled like PHP. But to be honest, these are usually smaller issues than input, output, and queries and so on. What you have to do is to profile your code. There is no like, oh yeah, I'm not going to use immutable code because it's slow. This is just bullshit, all right? Don't do that. Anything you want to have as performant is usually code that is affected, that has a greater impact than all log n, pretty much anything that has to do with sorting, with looping over structures, and so on. For other things, it's not so important. So please profile before saying, no, I'm not going to use immutable code because it's not performant. Other things we want to get rid of. Now, we want objects to be as immutable as possible. This means that we remove setters at all. Setters are a common anti-pattern. Who uses setters here? I use them. I'm guilty as well. Setters do not mean anything. In the original idea of object-oriented programming, objects, as Alan Kay described them, are just kind of like things that interact with each other. Interacting is not copying data from one another. It's I'm telling you what to do and you tell me what to do. But we don't share state, we don't pass each other data. Okay, so this is not what object-oriented is about. Instead, you code interactions, so your objects should have interactions, method that means something for the domain that you're working on. So, this means that now that we got rid of the setters, the only point of injection, at least for services, for entities and stuff like that, is the constructor. You have a constructor, you put all the parameters there, and your object doesn't change over time. This simplifies things by a lot. You don't have to reason about mutability there, and when there is mutability, then you gave it a name. It is going to be user approved by administrator and stuff like that. Approve a user on a user object, or notify user of registration confirmation, whatever. Stuff like that. This is what happens. You don't code setters anymore. You don't say active, set active equal true. Okay? You don't do that anymore. This means that since you have your constructor now, and the state comes in from there, you don't have uninitialized properties. Uninitialized properties are what we usually call optional dependencies. So optional dependencies, they look like this. Anybody recognize this? We have a DB connection object. I did them as well. You have a constructor, and then you have a set logger. Now, I use the set logger just as an example of showing why this is broken. But basically, what this allows us to do is to have a connection object that, if a setter is set, if a logger is set, does some logging, otherwise ignores the logging. This is a big waste of time, because it will or will not log, it will be complex to test, and to be honest, it's just more logic than what it needs to do itself. So optional dependencies do not exist. Either it's there or it's not. Do not go in between and say, oh, it may or may not be there. There are two different scenarios here. There is a version of the database connection that logs stuff and one that doesn't. So what you do is you separate them out. But if you really need logging, then instead code it like this. You make a DB connection object, and you say it's always going to log stuff. And then you inject the logger all the time. Okay, there are no setters here. Okay? And then, when you create a DB connection and you do not want to log, then you just inject a fake logger instead. So you remove entirely this responsibility of the connection object to decide whether it should log or not. That is not its responsibility. You just have a fake logger because you're not interested in logging. Okay, so other things to do. Any public method that is not strictly required is not needed. Don't write it. Okay? It's unnecessary because you can find a different way to make it work. Okay? If you have a public method that does one thing and you have another public method that does a similar thing, maybe try to get rid of one of them. Okay? The problem is that once you wrote a public method, you're going to maintain it for the rest of your life. It's pretty much like a child, okay? This is Stefan Priebsch, but basically, this is really, really true. Once you created this method, you can't modify the parameters, you can't modify the signature, you can't remove it, you can't make it private, because consumers of your API, of your abstraction, are going to get a BC break. And this means angry users or customers, okay? And a major version bump. So, other things to remove. Avoid having logic switch parameters. So here we have an example. We have a spammer object. Spammer object is a very common object in our domains, but we have a public function spam, so we send spam to an email address, we pass in some template that we want to render, and then we say, show them the opt-out link or not, okay, as parameter. So what we can do is, basically in here, then there is some decision logic, whether we are going to render this link or not. What we do is we split them out and make them two methods instead, so that the intent from the caller side is much more explicit. So what we do is we split it like this. We have a spammer object. Now we can send some illegal spam, okay, which will not show the opt-out link. And then we can send some apparently legal spam, okay, which has the opt-out link, but we're going to ignore it anyway, and we're going to tell them, oh yeah, we received your request, we're going to probably remove you from the mailing list within the next 72 years. Other things, all states should be encapsulated. So object-oriented programming, whether you like it or not, is about hiding stuff and interactions. So you don't want to tell them what you know, you just let them tell you what they want you to do, and you tell them, yeah, I can't, or no, I cannot, and here's what happened. Pretty much that is what happens in object-oriented programming. And by the way, there is functional programming, I'm not really talking about it here. Functional programming kind of fixed all this by introducing another set of problems. We're not going there. So, we have a bank account object, and we use a setter here. That's just because I want to make the example really simple. So we set the last refresh to a date time where we say last refresh. And then what can happen here is that we have a current time, which is a new date time, and I say bank account 1 set last refresh with the current time, bank account 2 set last refresh with the current time, and then something happens over time, some logic happens, and then someone somewhere does current time sets timestamp with a new timestamp. And now what you got is a state leakage, you got a shared pointer pretty much, and you got a problem there. Two things are referencing the same object, but that object keeps mutating. So anything that is mutable state should be dereferenced. So to fix that, it's actually really simple to do. So what you do is either you accept a date time and then clone it. This is actually dereferencing. If your date time is not a simple object, but it has multiple nesting levels of objects, you need to make something called a deep copy. And there is a library called deep copy for that, but it kind of shows that something is broken in your logic if you have to do that. Or you inject an immutable object. So as long as you make as much as possible immutable, you're not going to have these problems. So you see, these bugs all get eliminated. You start adding just one of these rules, and many of the others actually go away. Many of the other problems go away. The same thing can actually happen in the constructor. So you have to be very careful about the constructor as well. I'm going to assume that money here is immutable, but you have a date time with the transfer date of that money. You just want to clone it, or you want to have a date time immutable there as well. All right. Any external access to state includes also the subclasses. The reason is very simple. A subclass got written after the parent class, which means that it's a new use case scenario. You have a new scenario that requires some understanding of the problem that you didn't have initially, or maybe you're solving a different problem. So you should make all the state of your parent class private so that the child class doesn't have to take decisions such as, do I access state via getter? Do I access state directly? Do I check this thing? How does the workflow how does the internal state mutate in the parent class if it mutates? And this is really, really common. People have these protected properties everywhere, and then you change the parent class and all the child classes break. Even if those are kind of like private stuff, you should not touch it. So by default, please use private properties. If you make a protected property or protected method, then you need to have an already prepared design of how this property and this method is going to be used. It is simply an API for child classes, but if you do not design for inheritance, then please do not make it accessible. Make it private unless there is a reason to make it protected, and it must be a good one. All right, other things that are interesting. A public method on an object is kind of like a transaction. Let me show you a good example about this. You have a bank account object, and you have an add money method, and then you have a mark bill paid with money. Okay? And what you do, well, these are on the same object. Okay? So what we do is we call it like this. So somewhere in a controller, in a service layer, in a command handler, whatever your architecture looks like, we are going to call these two methods in sequence because they are strictly related. We are adding some money, and then we're saying, oh yeah, this bill got paid. So we're adding it to a log of paid bills. But what happens if add money succeeds, and then mark bill paid with money fails and throws an exception? Right? So now you got some problem there because your state, your internal state, is inconsistent. So you have the money, but you threw an exception, so they gave you the money and you can now run away. Which, to be honest, is positive for a business, but the problem is that these methods are part of a single interaction. They're temporally very coupled. They must happen at the same time, and this is what a transaction is. So what you should do is you make them private, make private this, private that, and then you have a single public function, pay bill, you pass in the bill and the money. Now what happens is that since this is all private API, you know exactly which one of these interactions can fail for whatever reason. So if anything fails here, you're going to write the code to roll back the state. So if there is a state mutation, you're responsible for keeping internal state consistent. And this really makes you paranoid about APIs of your objects, because you now start exposing very, very little public API, because people love to call one method, then the second one, then the third one, like setters, right? So this, so that, throws exception, right? This happens a lot. Now, often this just causes an application to crash, okay? You got an exception, it just fails, crashes. But if your application recovers, then you have invalid memory, and you're going to have trouble. So this is pretty much how it comes out, and it's much simpler, to be honest. Other things that are very broken in our usual coding is that we assume that a method, when we call it multiple times, is going to give us the same thing over and over and over again. So this is something really common. Took a simple example to show you something that is very, very common. We have a controller, we get the request from the controller, and then we get some parameter called user ID. Simple, right? Then we get, again, the controller request, get user roles. What is happening here is that these two methods, we assume that they will return the same request object. And this is a big assumption. The API does not give us that assumption. At least with our type system, there is no way to enforce that a method is idempotent, so it does return the same thing over multiple calls. So subsequent calls are assuming the same state, but this may break. There is no guarantee that this is true. For example, if we have a clock object and we call it multiple times throughout our application, and our application takes a lot of time to run, when we compare this date-time object with each other, they're not going to be the same. We always have a new one, and microseconds change anyway. So be very careful about them. Instead, well, there is a bug here, but you just cache it in a variable. This has nothing to do with performance. It's about API safety. You cache it in a request parameter here in a variable, so you code idempotence for the API, and then you use it like this. And this will give you a bit of certainty, right? Assertions. Whenever you receive any data that you are not sure about the structure of this data, like for example an array, you want an array of strings, you want an array of integers, you want an integer that is greater than 100, you want to assert invariants. Invariants are something that they teach you in like the second week of computer science at university or something like that, so nobody remembers them. But they're really, really useful. So whenever you have an API and you accept a value that is not strictly typed, you want to ensure that it is within the expected boundaries. So you enforce very strict invariants. For example, here is something very horrible that I hacked together, and that's just because I want to do some hackery. But we have an array of wagons, and there is no way in PHP to say that I want an array of wagons here. That's because the type system is very limited. So what I have to do is I have to loop over these values, and I have to verify that they are wagons. So what I'm doing here, I'm splitting it, which is actually doing another interesting thing. This ensures that my array is 0 indexed, and that all the indexes are adjacent. So this is actually really interesting. And then I'm type hinting here. So this will break on HHVM, which is also interesting. But in this way, I'm checking all the values for type safety. I'm checking the structure of the array, and all in one shot. So there is no need to do this. There are libraries for doing it. You can just use assertion libraries. I just wanted to make something horrible that looks cool on a slide. But it works on PHP 7, and it's quite fast. So there are libraries for this. There is Eberle assert. There is also stuff by Web Mozart, who is the guy that makes the Symfony Form stuff. Just use those libraries, and you can say, just assure that this array is 0 indexed, and ensure that this array only contains integers, and so on. So, but if you have control over the data that flows inside your system, so you're not getting data from the outside, what you want to do is you want to just type hint very strictly, so you don't use mixed. Anybody has at param mixed, right? Yeah, right. That's like, okay, yeah. This is like, sorry for the wording, but this is like at param, fuck you. That's pretty much what mixed means. So here's a good example. One of my sad examples, because I'm probably too German to make happy examples. Like Struwwelpeter and stuff like that, like really creepy. Anyway, so prisoner transfer request, then you have a mixed parameter, so we say this is an alias for whatever. And then we have an access level, and it may be false if no security is needed, then true if some guards are required, then null if it's to be decided, then 10, then 20, whatever. And this is what happens with an organically growing API, and this parameter gets overloaded with more and more and more meaning over time. Because business comes to you and says, oh yeah, we want a quick patch, and this needs to work. And then you keep adding more and more behavior to that single value, because it's some drop-down in your application for some reason. And this is a WTF barbecue. Like, nobody's going to understand how to use this API, and nobody's going to find out a good way to debug this. It's going to be a source of bugs. This is a source of bugs, absolutely. So what you do instead, you encapsulate somewhere, and you say, I have a security level object, which is a value object, and it encapsulates these rules. So you move out this mixed, and you make it a value object that includes those rules that you defined over the ages of your application. So value objects are really, really powerful. In general, and this is something that I learned from Matthias, you can design a system starting just from value objects. You design the entire system from value objects, and then define later, when you get stuck, you start defining entities and stuff like that. But you can really define a system just with value objects. and things passing in value objects and returning new value objects, which is really, really interesting. Value objects are a way of ensuring consistency. So you have to, you pass in some data to this value object, the value object does the validation, and then the type system keeps it consistent for you, which is really, really cool. So whenever you have an API that expects, for example, an email address to be passed in, why pass in a string when you can pass in an email address value object? You know that that value object is going to do the minimal validation to ensure, yeah, this looks like an email address. You don't know if that email address is an email address of one of your users, okay, because it's a value. It doesn't know anything about your database. It just exists on its own. It's a value. But at least you don't need to check if that string looks like an email address everywhere. Just pass it in through. It's in your address space, which means that nobody can tamper it. Nobody can create an email address object with some invalid data because it's inside your application. It's not over the network. You're not serializing and unserializing this. You always reconstruct them. So don't use serialize and unserialize on message queue. It's a silly idea. Always revalidate your value objects when they cross boundaries through different memory spaces, which means different running processes. But now you don't need to validate it anymore. You pass it through the layers and simplifies your stuff massively. Okay? Same for the return types. Do not return mixed. It is really, really, really an offense to who is going to use your API. You're really, really making them, well, you're making their life harder, and your life as well, because you're going to use that API if you wrote it. Otherwise, why did you write it in first place? All right, so value object again. A good example of this is who does use Zen validator, maybe? All right, Symfony validator. Who uses it? What validator do you use, people? Do you validate data? Sorry? All right. But a good example of this is a validation API. Instead of passing in an array of values and returning an array of values, or passing in a value and returning a value, and then having another getter that tells you if the value was valid or not, and which error messages there were. Instead of doing that, what you can do is you pass in a set of values. Okay, you just pass in a new value set, or a not validated value set, which may be an array or a string or whatever. And as a return value, you get a validation result, and the validation result contains whether the values were valid. Okay, they contain the actual values, the valid ones, and they contain the error messages. So you pass in an object, you return an object, and it's very, very simple, and it simplifies things by a lot. Okay. Other things that I don't like. Fluent interfaces. Fluent interfaces are very common for query builders and stuff like that, but a lot of people love adding them to all the objects. Now, if you apply the transactionality principle that I was talking about before, there is no point in having a Fluent interface in first place, because you should have a single method call for any state mutation. But in general, there is another problem with Fluent interfaces that is much more, I would say, philosophical. So here are 3 examples. These are perfectly equivalent. These are all valid. I'm not asking you to look for a bug. These 3 all work, and they do the same exact thing. Okay? Now, anybody remember what principle I was talking about initially? Right? No? What is wrong with this? We have 3 ways of doing the same thing. Yeah? Well, yeah, that is true. It is not immutable, but you can't do everything immutable. You have to strive for immutable, that's sure. But you can't do everything immutable. For example, entities are not immutable. A user object changes over time. You can't really make an immutable user object and have 2, right? But the problem with this is that it's not Poka-Yoke. You now have your same API, and you have 3 ways of using it. This means that there are 2 ways of screwing it up that are absolutely not needed. Just give them just the rope for hanging themselves only once. Don't give them 3 times the rope. There is no need for doing that, all right? So there is only the need for one way of doing it. There is no need to make 3 possible styles of coding of the same thing. So this works fine. There is no need to return this, or even the fact that we can't ensure identity on a Fluent interface because the type system doesn't give us that makes it very unsafe to use. Right, there's blog posts and stuff like that. Anyway, other things that I don't like. Make your classes please final by default. Unless you design a class to be extensible, okay, you start from a design and you think, oh yes, I will design this so that the usage of this class is that people extend it and do exactly this. Okay, you need to think about that when you start designing a class that needs to support inheritance. Otherwise, there is no reason to design a class that is not final. Now, every time you have an inheritance, the child class in the inheritance is a different use case from the one that you designed initially. Okay? So, there is a very good rule of thumb to when you want a class to be extensible or not. Now, take your class, which is a user object, for example, okay, and now turn it into an interface object. Okay? So take the class, strip it of all the body, of all the methods, make it into an interface. Now extend the interface with another interface. Okay? So you did this operation. Does your additional interface, the sub-interface, does it add some semantic meaning to the parent one or not? Okay? This is the rule of thumb. So if you manage to find some additional semantic meaning for the sub-interface, then you can use extends. Otherwise, it is not a good idea to use extends. All right? If you have meaning, then you can use it. Otherwise, you just don't need it at all. Again, blog posts and stuff. Traits. Who uses traits? Don't. Please. Traits are an interesting construct. A trait does not exist at runtime, which means that it is a piece of code that is going to be copy-pasted all around your system, which means that if you fix a bug in a trait, you're probably going to introduce a bug in all the other use cases of that trait, because they don't expect the trait to work like that. Because a trait is not an abstraction. Therefore, a trait is not reusable, which is what I was saying initially. A trait is code, and code is not reusable. You're copy-pasting code with a compiler, and we were all excited when it came out in PHP 5.4, and since then, I had no use case for a trait whatsoever. Instead, what you want to do is not really reuse that code with a copy-paste approach. What you want to do is you have to inject maybe a collaborator or have an abstraction that is shared across the other implementation, but it is injectable, and it does solve the problem that you tried to copy-paste into all the other implementations. I found a scenario where a trait maybe makes sense, and I didn't manage to destruct it yet, which is collection APIs, like implementing collection APIs multiple times. But to be honest, I never found a reason to make 3 collections that have the same and have different names. So, yeah, we'll see about that. But in general, this is where the dry principle is making more damage than what it is actually helping. So we are coding our code inside the trait so that we avoid repeating it multiple times in the implementations because we don't want to repeat ourselves. But in the end, what we get is just a possible source of bugs that now propagate throughout the code base in a much more extensive way. Right, ensuring deep cloning. I was talking about that early, but basically what can happen is that when you have any cloning of objects, you are pretty much making a copy. Now, making a copy is a state mutation, so you're taking an object, making a new one, okay, and you're copying the state. You're not making a copy through behavior. You're not saying, give me a copy. You're saying, copy this, which means that it's a very low-level technical operation. And if you don't make it right, then you will have shared pointers everywhere. So if you don't clone this time here, you're going to have the same date time bug that we saw before. The other thing that is a bit annoying about cloning is that PHP allows it on everything. So the point is that cloning is an operation that requires deep understanding of the state and the internal components of your objects, which means that your clone operation, while it looks like this tiny, insignificant, and pretty much harmless operation, it may actually do things that were not foreseen before. So PHP by design allows cloning anything instead of saying you can only clone things that are clonable, which is, to be honest, this entire thing that allowing anything to be cloned without knowing how it works internally is kind of a contradiction. So maybe the best solution for this is to disable cloning. Okay? If your object cannot be cloned because you didn't design it for that, then don't clone it. So this is just an example. We have a human object, and cloning humans is legal, at least for now. So it throws an exception. I got other suggestions, which are to just make it private, make the method private, and it will just throw an exception, like you're trying to call a private method. And this is a simple solution to the problem. And this is really, it is just because somebody is going to use your API, and they're going to tell you, oh, I can't clone this object because all my system breaks down. And you're like, why are you cloning it? Oh, yeah, because I can, right? No, you can't. Now you can't. So you broke your BC compliance here, but at least you told them exactly what you want about your objects. Yeah, that is actually yeah, that is a good solution, to be honest. This could be an unclonable trait. But yeah, I'm starting to contradict myself. I need to stop talking now. All right, the same thing happens for serialization. All right? Serialization is a very similar concept. For example, who here uses Doctrine, the ORM? So anybody tried to serialize the entity manager? All right, it's just an example. But this is what happens, okay? So you have this thing that is not supposed to be saved anywhere, and you're still trying to save it. So it can work sometimes, and sometimes it can't. But this is just because we didn't disable it. But is your object really serializable? Again, you need deep understanding of all the dependencies of your object, and all the dependencies need to be able to be put in a serialized state and in another state on a different machine. For example, PDO does this right. You cannot serialize a PDO connection, because you can't take a connection, copy it into a string, put it in another system, unserialize, and hope that the connection works. It's just not how it works, right? This is just how it is. So again, you need to know about the life cycle of all the data inside your objects. You need to know how they behave. They need to know how they are serialized and so on. So it's a big contradiction. You have moved again from behavior to very technical, low-level state mutation logic. So is your object even supposed to be stored somewhere, or was it never designed for that? Is it something that you can store? Can you store your customers? Yes. But can you store, I don't know, your business logic? Probably a bad idea. Every insurance tries to do that, and they fail miserably every time. So again, throw an exception in sleep. Don't use sleep. I use sleep, but you shouldn't, right? Throw an exception, make it private, whatever. Other things that you can do is serialize only if it's serializable. We have an interface for it. If it's not serializable, then don't try serializing it. But again, you can't expect consumers of your API to not do things. They will do things. They will do bad things to your code, and it's going to be you as well. Okay? You are going to do bad things with your own code. So limit what you can do. That's the only way to actually enforce things. Unit testing. All right, so what you need to do in unit testing is to test every scenario. Anybody doing actual unit testing with every branch coverage? Yeah, old school, that's good. So in general, when you have an API that can branch off into different things that can happen, you want to have a unit test for every one of those scenarios. So all of them, and it's pretty much the idea is that you need to bring the CRAP score below 2. The CRAP score is a ratio between the number of tests and the number of paths inside your code, which means that you will start having much simpler code, because as soon as the paths explode in complexity, you are going to cry. And you also will have a lot of tests, even for simple API. This will make you cry. It will be very, very frustrating at the beginning, but it will teach you to stop implementing every idea you had. It's like reality. It's like, no, all right? So you will love having less features and telling your project manager that you can't implement everything. So here's an example. We have an out service, and the out service allows us to authenticate, returns a Boolean, and throws a bunch of exceptions. And then we have a myLogin functionality, which uses the out service as dependency, and then has a login function, which does the authenticate with some basic credentials, which receive the username and the password, returns true or returns false, and then some stuff here. All right? Let's assume that these are all the only branches. How many tests do I have to write for this? Yeah? Yeah, pretty much. Well, you have to write at least 5, because I didn't show you what this is. All right? But you have to write at least 5 tests. You have to write a test for Boolean true, for Boolean false, for this exception, for this exception, for this exception. And maybe one for generic exception to verify that they bubble up as well. I don't know, the latest one, the last one maybe is a bit exaggerate, plus eventually tests for invalid values here. This is a bit extreme, but that's how it is. Now, if you use a testing tool like, anybody know of Humbug? Humbug, the mutation testing framework? Yeah? If you run a thing like Humbug against a test suite that does not implement all these tests, it will find problems in your code, okay? All right. These were all the scenarios. All right, to recap, these are all suggestions. I'm not telling you this is the way of writing PHP. This looks more like Java, I realize that. Okay, but I don't have a reasoning of saying, yeah, you shouldn't write PHP like this. I can't find reasons against writing code that is secure by default like this. You don't trust any code. Code must be replaceable. What you do is you trust in the abstraction. You say, oh, this abstraction says returns a Boolean, so I'm going to trust that. But you're not trusting the actual implementation. The implementation must be replaceable at every moment. You want to reduce all the features inside your code to a bare minimum. Solve the problem that you have right now. For the next one, maybe build another abstraction later on. But don't do it immediately. You ain't going to need it. Enforce strict invariance in your code. Your value objects should do that. So convert every value that you upcast via an invariant into a value object. That simplifies stuff. All right? So you await strict values. You return strict values. And I hope that was useful. All right? All right, thank you very much. Are there any questions? We got, I think, 5 minutes.
Okay, in case of XBase, please be careful with value objects. If you have 4 or 5 columns in a table and build it up with a domain model, it will do a where call like this and call like this and call like 5 times.
Yes.
So you have to build an index over them. But
actually, you don't, because if even a partial index is hit, it's going to use just the partial index. If you have an index on 2 columns, it's going to be on that index and then filter the rest of the values from there. So that's what happens, at least in a normal database. You have a filter on 5 columns, okay, and you have an index on 2 of the 5 filter columns. That's not a big deal, usually. Yep.
Should value objects be always similar to strings?
To strings, if Pretty much, yes. You should have at least a representation that you can push across the network or across storage and stuff like that. A value object is a value, okay? So you can convert it from this to this to this to this. The important thing is that at every conversion you revalidate it. You don't trust it to be valid later on, okay? You just don't JSON serialize and put some values. We have reflection and stuff like that. So that's all there is to it. You just revalidate at every serialization, because that's actually what the value object constructor is doing. You take a string, an integer, whatever, you upcast it to a type-safe version, and this upcast needs to do the invariant check. But yes, you can upcast it, downcast it, downcast it, and it needs to move across systems. Right?
I have a question about traits.
Yeah.
Well, the point I think is, if I understand it correctly, is don't use traits because you can't trust the code, because the code might change. But so would any third-party code, if you're using an object that implements any kind of interface, but it's not outside of your team, because it's a third-party developer, whatever.
Yeah, no, okay, when you use an interface, you trust only the interface. So when it says Boolean true or Boolean false, you trust it blindly. For example, an interface that says whether a certain email address exists or not in your system, and somebody else codes this for you, and maybe it's a microservice, whatever, some buzzwords, bingo stuff, but you trust it to return Boolean true or Boolean false. And that's all what this API does. You trust the interface, and then the implementation can be rewritten by 10 different companies as long as the interface remains stable. Meanwhile, the trait is just code. There is no specification for it. There is no interface for it. Every time you trust, you modify the trait. Instead of depending on a piece of code, you are importing a piece of code. So if the trait got written by somebody else, then you have a problem. For example, you have a trait with the, let's say, a soft deletable trait. Soft deletable trait that defines how soft deletes work in your system, and you implement it on 20 entity types inside your system because everything needs to be soft deleted. Please don't do that, by the way. Then now, if somebody changes how that trait behaves in a certain point, all right, it's not an API, it's not returning something with a contract, it is actually changes that you imported in your code. So you implemented it on 50 entities, whatever, and one of them somewhere is going to break because you rely on it because it's imported code. So you just trust, it's just code that you copied in and state that you copied in. That's the problem with traits. Does that make sense?
Yes, in a way, but I don't think, I don't grasp the difference between like using a soft delete service. Somebody could change the way the service behaves. The interface would be the same.
He
and
could say
will
that
return true, yeah, but it just deletes everything. Like, so I have to think about it.
The fact is that the external service may return false at some point, but that's all it can do. It can still only change inside the boundaries of the abstraction. If it changes the actual abstraction, then you have a BC break and you have to adapt your code to the new abstraction. But it can't escape the boundaries of the abstraction itself. That's the point.
Okay, thank you.
Any other questions? No? Beer? No? All right. I can't, I must drive. All right, thank you very much.